Well, hi, everybody. Hi, chat room. We're just sort of getting things started here, aren't we? I need to get with the program. I'm a couple minutes behind, but we're in pretty good shape. We're in pretty good shape. I guess I need to start a recording. That would be good. I haven't even done my podcast stuff. You get to see the behind the scenes. Let's change this view. That looks good. Let's put this up here. That looks fabulous. Let's maybe not make that quite so bright. Hey, chat room. Hi, everybody. Let's start a recording. That would be good. Something we can have for later. That's where all podcast stuff comes from. Where is my podcast intro? I haven't even put my headphones in yet. I'm not sure if you're even able to hear me. I think you are. Today is February the something. I don't even have my clock up. I need to fix all of that. See, it's I got to frame myself. Nothing is quite ready to go. Running and gunning today. It's going to be a good study group. I got questions today from the N10-007 Network Plus study group today. Is that what we're doing? We're doing the Network Plus? I think we are. I think we're in pretty good shape. Let's get some headphones on. I'll be able to actually hear what I'm saying. I mean, I can hear what I'm saying. You know what I mean. Today is February 23rd of 2021. Now I can hear me. That's so much better. Let's update these things here so I don't say the wrong date. Today's the 23rd. The 23rd. It's got to go an RD in front of it. I'm James Messer, and you're listening to the Professor Messer N10-007 Network Plus Study Group. This study group was recorded on February 23rd, 2021. If you'd like to watch a video replay, visit my website at professormesser.com. I'm James Messer, and you're listening to the Professor Messer N10-007 Network Plus Study Group Aftershow. This Aftershow was recorded on February 23rd, 2021. If you'd like to watch a video replay, visit my website at professormesser.com. All right, the hard part's over, everybody. That was it. Let's pop up in the chat. We'll talk with the chat room for at least 5 minutes, for at least 3 minutes. That's what happens when everything goes so quick. It goes so fast. All right, we'll put this over here. We'll put this over here. This needs to go over here. Whoa, there we go. That looks all great. Hey, chat room. Hi, everybody. XTN passed their Network Plus yesterday with a 749. Congratulations. That's fantastic. It's always nice to hear when everybody is able to make that happen. What else we got going on? Let's make sure recordings are going. That recording is going. This recording is going. Videos look good. Whoop, there's our laptop. Everybody looks good. Have I ever messed up that podcast message? Absolutely. All the time. But you don't normally get to hear it. I normally do it before I go live. So you don't get to hear me stumble through it sometimes. Sometimes I've got the date written wrong because I'm really just reading from that script that was in front of me. And when you start reading from a script, you sometimes aren't thinking about what you're saying. And the script, if somebody went in and changed all the words of the script, I wonder if I would even recognize that. Would I even notice? So our first hour is all Q&A. Stick around the next 2 minutes. 1 minute, we'll get started with the study group. And then after we're done there, we have an hour of Q&A where you get to call me. No, it's not a green screen. That's a real background back there. I know it seems like it's so dark, but that's all real stuff. This is all real. That's my real keyboard, my real motherboard. It's not a picture. There's actual stuff behind there. I need a stick of some kind that I could poke at because I don't want to leave my desk to do that. But that is real back there. That is just the lights are out up here. You can't even see them, but there's a couple big lights. See how my hand is sort of lit there? There's lights up here and there's lights behind me. So you're seeing the lights behind me illuminating the back wall there. That is a cricket ball. and that is an electronic Rubik's Cube. That is correct. Okay, we need to pause this so I'm not looking at myself the whole time. There we go. Oh, what I should do is just mix things up so it's different every time you see it. There's just different things there all the time. But I don't really change much of it around. I guess if I have to dust. Oh, it's 12 noon. Boy, that happened fast. If I was just a little bit better with my time management today. Everyone has that day, right? Oh, I don't need that. I need a keynote, and we need to get a green light, and we will get started, everybody. Green light on the keynote. Yes. The chat room link, well, that is, you're in the chat room. If you're putting things in there asking what the chat room link is, then you're there. That was easy. I like it when that happens. Let's get this started because we need to do a study group, everybody. Here we go. This button here. Hello, everyone. Welcome to the February 2021 Professor Messer N10-007 Network Plus Study Group. This is our monthly study group where we are able to ask you questions on this side from the N10-007 Network Plus exam objectives. And then live and in person, you're able to answer all of these questions online. We'll talk in a moment about how you're able to make that happen. Thanks for being here. We've got a lot of folks who were here. I've kind of jumped into this at the last minute today because of bad time management. You can rewind and watch the pre-show at me scrambling around. But here you are. You're ready to go. So if you'd like to participate with our Q&A, you can simply pop up a new browser window, visit professormesser.com/QA. There's a question waiting for you on that page. There is a question. I promise. It's right there. You'll see it. The questions are also available on a mobile app. The mobile app is called the Socrative Student App. Go to your favorite app store and download the Socrative Student App. Socrative is the service that we use whenever we are doing one of these live events. If you're watching this on the replay, this isn't going to be available to you, but you can still follow along with the live stream, with the replay of the live stream. If you do download that Socrative Student App, it will ask you for a room name. The room name is Professor Messer, all one word, PROFESSORMESSER. Make sure you spell it right or there won't be a question there. The question that will start everything today is a question from last month. It is our study group rewind question that asks, which of the following would best describe a Z-wave network topology? Would that be a ring, a star, a mesh, or a bus? Now, if you think you know the answer, you need to lock in your answer by visiting professormesser.com/QA. Please no answers in the chat room. Please no hints in the chat room. So we'll come back to this question in just a moment. In the meantime, I want to thank you for being here. We have so many things that we do throughout the month for Network Plus. Don't forget about the Network Plus videos we have on YouTube. Our entire course available for you to watch absolutely free on the YouTube. Go to professormesser.com/YouTube, which will also be a great place to subscribe and click the thumbs up button. There's one thing that every YouTuber would like from everyone watching, and it's really those two things. And it's free. That's a nice thing you can do to help support the site. We also have weekly Network Plus questions. They usually come out on Tuesdays. You can find those on professormesser.com/Twitter. There's also questions on Instagram, same questions, but there's a pretty picture to go along with it. And who doesn't like that? Find that at professormesser.com/Instagram. The N10-007 has been out since March the 1st, 2018. We expect that it's going to be retired probably the first quarter of 2022. So a year from now, you will probably start to see this. That's probably when I would expect to see this retired. So you've got plenty of time to study. If you're here in February of 2021, this is the right certification for you to be studying. This exam is 90 minutes long. It's a maximum of 90 questions. It's only a single exam, and you have to score 720 on a scale from 100 to 900. Kind of an odd scale, odd system for scoring this, but that's the way it works. The exam itself is mostly multiple choice questions, but there are a handful of performance-based questions at the beginning. So we'll talk more about that as we go. Don't forget to get your hands on those exam objectives. You can find a link to those at professormesser.com/objectives. I have taken, of course, all of these videos that I create, and I put them on YouTube for free. And if you're able to watch them on YouTube and just stream them whenever you would like on demand, please, you're more than welcome to do so. I've also taken all of these videos and put them into an offline form that you could put on any of your devices. You can watch on your desktop, your laptop, your television, your mobile devices. I've also got audio versions of this in MP3 format. I've got my course notes. I've got my exclusive Exam Hacks ebook, which is more of a book that talks about the exam process rather than any specific certification exam, because there are some strategies for taking the exam that I think are important. So I wrote a book on it, the Exam Hacks ebook. Don't forget that if you get this Success Bundle for Network Plus, it also includes study group Q&A access, preferred access. So all of this really is in one place. You can download and have access to all of this from my website using the Success Bundle. You can learn more about that at professormesser.com/netsuccess. We do these live streams every month. They're free. Anybody can watch. You can connect from anywhere in the world and participate with us or watch the replay. There's also an audio version of this available for download afterwards in podcast form. You can find that at professormesser.com/podcast. My A+, Network Plus, and Security Plus study groups are all there. And if you have a podcasting program, there's an RSS feed link there. You can add it to your podcasting program and have access to those. Also, if you have a streaming service you like to use, if you like Spotify, if you like Google's podcasting front end, if you like in almost any podcasting front end at this point, you can search for Professor Messer. They are in there as well. About a day after this, you'll notice that the YouTube video descriptions for these study groups have timestamps in them. And the timestamps are really useful for finding exactly the information you're looking for. My marketing manager, Lori, has to go back through here and listen to this. Hi, Lori. She's watching the replay. Everybody say hi to Lori. She watches the live chat go by in the replay. So you should be able, of course, to find those. All of these are updated, and you can go back years with these to find that, and they become very useful if you're trying to find information. Let's go back to that question we asked originally, which was, which of the following would best describe a Z-Wave network topology? Which of the following would describe that? Would it be a ring, a star, a mesh, or a bus? Well, first, I guess we need to understand what Z-Wave is, but first, let's see how you answered. You can see that 84% of you say it's a mesh is what Z-Wave is. 11% said no, it's a star. 3% said a bus, and 2% said a ring. Well, Z-Wave technology is one that's been around for a number of years. It's commonly associated with Internet of Things, or IoT technologies. So if you're doing any home automation, many of your devices are connecting to each other using Z-Wave. Now, because of that, they will set up and connect all to each other without you having to do anything. So you can have these Z-Wave technology products all over your home, and the device on one end of your home may not be able to directly connect to the device on the other end of your home, but that's okay, because it will simply hop through all of the other devices in the middle because it's a mesh. And that mesh makes it very easy for us. We don't have to worry about it. It uses frequencies that are publicly available for you to use. But that is the technology that is used by Z-Wave. It means the 83% of you that chose mesh got it absolutely right. That is the right answer. It kind of gets us going. This way now you know how to get into the Q&A. Just stay on that page. The questions will change as I click the buttons on this side. And, of course, you're able to go back through and kind of see, as you're typing these things in, what options are available, and then the answers will show up on this screen. You'll be able to watch it all the way through. Let's do some new questions, though. I don't just have old questions for you. I've got questions that are brand new. One of the things we do in the study group is the first new question of the month is not a multiple choice question. The multiple choice question is one that has a question, and then you can choose from the available answers, which means on this one, there were 4 answers. We had a 25% chance of getting this one right. even if we didn't really know the answer. Well, instead of doing that with the first handful of questions on Network Plus, you're going to get questions that are not multiple choice. CompTIA calls these performance-based questions. Becomes handy to have those performance-based questions. Whenever you are working through your exam, don't worry. It's only about a handful, 5, 6, 7, or less than that even, to be able to do that. So feel free to go through and become more familiar with those. And go back to all the other study groups too. Our older study groups have different performance-based questions with each one of these. I have for you the first question of this month, a performance-based question. This one is a fill in the blank. So hopefully it's not too hard of a fill in the blank. It's more of a visual question. So those of you listening on the podcast may want to flip over to a video replay of this because it asks to name these connectors. And I have 4 connectors on the screen, an AB, a CD, and you can go through that and figure out what those connectors happen to be. I want you to type in what each of these is. So it looks like I have a mixture of different connectors, A, B, C, and D on the screen. If you're looking at this in Socrative, you can see these as well. This is also one of these situations where these are all very different. So you do have to know what these differences are and what they do on the screen. So become more familiar with these interfaces. They are part of the CompTIA exam objectives. If those of you that want to answer this, you want to go to professormesser.com/QA and just type in your answer for A, B, C, and D. And remember what you put there because it doesn't show you once you input your answer. So keep in mind what those happen to be. Please don't answer in the chat room. Please no hints in the chat room. We'll figure out the details for this. The connectors we have here, in fact, are all connectors I have worked with in my professional career. You probably will in yours as well. So that's another one that can help you as well as you're looking at these. I probably have used some of these more than others, certainly. But I guess it just depends on what you're doing to be able to have that there. That might help you as well. So I don't know. If you ever worked through connecting to these physical devices, this can really, really help you. I think that the key to the Network Plus exam is being able to see these on site. It's also going to really help you to be able to see these if you are working in a data center, in setting up a network. You want to be able to look at an interface, whether it's on a switch or whether you're holding the cable itself, and know what kind of interface that is, especially if you need to buy more cables. You need to be able to tell somebody the types of cables that you're using. This one's difficult to Google, isn't it? So no Googling. We're going to figure these out on its own. Although I think I did get all of these pictures from my stock photo library. Don't do any reverse lookups. See, you can't do that on the exam anyway. So let's take a stab at it. Maybe you know what at least one of these is. This is a question that comes up often is, what if I got 2 of these right and 2 of these wrong? Do I get partial credit? Well, we don't know. We're not exactly sure if you get partial credit or not. So CompTIA said in some cases we do get partial credit, and they've also said in some cases we don't get partial credit. So that's your option there, is to at least go through those and figure out the details. We have a few people that have locked in their answers, so let's step through each one of these one at a time and see if we happen to know what these are. We'll start with the one on the far left. We'll start with letter A. This one right here is one that should look relatively familiar. That's an RJ45 connector, most likely used for an Ethernet connection, although it can be used for other purposes as well. But RJ45 is that type of connector, most commonly associated with Ethernet. I have some RJ45 connectors that I use for serial communication. So it's not always used for Ethernet, but I think most commonly, the vast majority of RJ45 will be for your Ethernet connections. Next on the list is B. This one clearly is a fiber connection. I mean, that's not copper, right? That's a ferrule on the outside. You can't really see the fiber. The fiber is really on the inside of that very hard ferrule. That ferrule that's around it is to protect it so that you don't mess up the fiber that's on the inside. So really the fiber is just a tiny little dot in the middle of that. But the type of connector used for this fiber connection is ST. Some people refer to this as straight through ST. It's a good way to remember it. It's not technically what the ST is for, I don't think. I think we made that up after the fact, but it's a good way to remember it. It's probably one of the most common because it's one that's been around probably the longest. It's one of the original fiber types we were starting to use for local area networks and wide area networks. And it has a bayonet connector on it. So you push it in, you twist it like a quarter turn, and it locks it in. So if somebody tried to pull on that fiber, which you should not do, but if somebody did try to pull on that fiber, it would not pop out because it's locked in there. You have to unscrew it 1/4 turn to have it loosen up so that you can pull it out of that connection. So that is an ST connection. Third on our list, another one you should recognize is DB9. I heard someone, I was reading this somewhere, I'm not sure if it was in a chat room this week or if it was online in a Reddit or somewhere, where someone was saying they were disappointed they saw DB9 on the exam because nobody uses DB9 for a mouse connection anymore. And, well, we don't use DB9. They were right, I guess. We don't use DB9 for a mouse anymore, but DB9 is absolutely used for serial connections. If you're a networking person, then absolutely you have used DB9 because you've needed to connect to the serial port of a switch, of a router, of a firewall, of a device, and you absolutely need to have the DB9 there. You'll also see sometimes this will be, especially newer equipment, replaced with a USB type connection. So you don't have to have the 9-pin serial. It's more of the standard USB, either with the Type A or the mini USB type connections. But you will find a DB9 used on a lot of different kinds of equipment, especially if you're connecting your laptop to a serial connection. Your laptop may have a DB9 connection on it. Incredibly useful to have for networking people. I guess the person that was commenting on that wasn't really a networking person. They saw no need to have a DB9. They thought it was sort of worthless to have. But in fact, it's not uncommon for network professionals when they're buying their laptop to make sure that they either have a USB to DB9 converter cable, or they're just buying the laptop with a DB9 in it. It's hard to find a laptop with DB9 anymore, but they do make them. And it's so important if you're needing to update that router, that switch, that firewall. In my last job as a firewall systems engineer, I connected via my DB9 connection many times in a day. So it was critical for this. You may see this called a DE9, Delta Echo 9, which technically is the correct name for that interface, is Delta Echo 9. But DB9 is the DB, the B is the second letter refers to the size of the connection. And the original size was a 25-pin, which was bigger, which was the B size. And then we came out with this 9-pin size that was smaller, but the term DB sort of stuck. And all we changed was the number at the end. Instead of DB25, we turned it into DB9, but it's really DE9. So I would accept either one of those. Enough of the DB9 connection. Let's go to the next one, which is an LC connector, another fiber connector. LC. The Lucent connector, which is, again, I don't think the actual term for that. Is it, or is it? It's one of those where through the years, these oddly named fiber connections, we have created other names for it, other mnemonics so we can remember what it's about. But in any case, this is the LC connector. And it's another one where you'll find that LC being used. LC is also a very useful one to have. The LC connector is much smaller than the ST, which is why it became much more popular to have that LC connector. Because you could fit more connectors into a smaller space. And the people that make switches and routers and devices that plug in with these fiber connectors, they want to fit more interfaces in a smaller space because they get more value by having less room being taken up by all of these connectors. Very useful. So that's one of the things that I think, and you're right, chat room, I do talk very much on, especially with Network Plus, about things in the past. But probably more than any of the three exams that I mostly work with, which is the A+, the Network Plus, and Security Plus, Network Plus probably has the most longevity with technology. We tend to install our networking equipment it's very often an expensive installation. And so those connections will sit around for a very long time. It's not unusual to go into a data center and see wide area network connections that have been there for 10 years. So it's almost unusual to see the newer equipment when it's installed. We all get to stand around and go, oh, look at the new things. And we sort of know in the back of our head that's going to be here 10 years. That's going to be stuck in there for a long time. So that's one of those situations. So first on our list, the RJ45. Then we have the ST connector, then a DB9, then an LC connector. So a lot of great capabilities there. There are minor differences between those fiber connectors. You do have to look very carefully. That one almost looks like, you're right on the chat room, almost looks like an SC connector, but not quite. You have to look a little closer. It's hard to tell without a banana there, right? You aren't quite sure how big it is. You need some type of index, some type of ruler or a quarter, something that would everyone would be able to understand. But those are the 4 connectors. If you answered those and got those right, well done. Knowing the connector types is very important. There's other connectors you need to know. Make sure you go to the exam objectives, and you'll be very familiar with everything you need to know for the exam. Let's do another question. This one is multiple choice, but it is a visual question. I'm so sorry, people on the podcast. But I have a wire map that I would like you to tell me what this wire map is. The question asks, what kind of wire map is this? The possible answers are loopback plug, crossover cable, 568A to 568B, patch cable, or split pair. What kind of wire map is that? There's the picture of it. Is it a loopback plug, a crossover cable, a 568A to 568B, a patch cable, or a split pair? Now, if you think you know the answer, please know answers in the chat room. You want to go to professormesser.com/QA and lock in your answers. See if you happen to know what it is. This is one that becomes important too. Knowing and being able to put up types of connectors next to each other become really useful. So make sure you know which ones to look at as you're going through these. Let me give you the better picture of that. There it is. That's a pretty good picture of that wire map. It's nice when you can put the wires next to each other, the 2 ends of the cable. That's one good way to do it, and look at it. Although if you want a wire map like this, you would use maybe some type of wire mapping tool, like a cable tester, that might map the cables for you. So another one to be able to work through. Be sure to lock in your answer, professormesser.com/QA. Please no hints in the chat room. Please no answers in the chat room. Be able to figure this one out. What kind of wire map is that? What is it? Maybe you've used this wire map before. Maybe we won't fool many people on this one, but we'll figure it out. We'll be able to get through all of this and be able to answer what kind of wire map. And I have an interesting story about why this question showed up as well. Usually throughout the month, I see things online where people are arguing about what does what. We're trying to all figure it out, especially if we're learning this. Some of these technologies are just ridiculous to figure out the details of it. So this is one of those situations where I do want to kind of give you the backstory on this one when we talk about it. A lot of you have locked in your answer. Let's see how you did with this one. What type of wire map is this? Is this a loopback plug? Is it a crossover cable? Is it a 568A to 568B? Is it a patch cable? Or is it a split pair? Let's answer this. Let me click the show results button. See what we get. 63% of you say that's a crossover cable. 19% say that's 568A to 568B. Almost 20% of you. And then a 3-way tie for third, 6% apiece between loopback plug, patch cable, or split pair. So with 63% saying crossover cable, should we go with that, or should we maybe see what the differences are between this? Well, if you've ever had to plug in two like devices, like Ethernet devices, then you have needed a crossover cable. And that's exactly what this is. This is a crossover cable where we are effectively connecting the transmit on one side, or in the case of this particular cable, because this is one you would use for gigabit Ethernet, we're connecting the plus side to the negative side, if you want to think of it that way. We'll talk more about that in a moment as well. In most devices these days, though, you don't need a crossover cable. There's this functionality called an auto MDIX that is inside of that device, and it will recognize if you're connecting to a device over a straight through cable, and internally it will perform the crossover inside of your equipment, which just makes it so much easier. You don't have to carry around a crossover cable. Makes it so easy to be able to do that. But that is not that is written in the standard that you can do that, but it's also in the Ethernet standard that manufacturers don't have to do that. So in some cases, you do have to perform crossovers outside of the box. And as people are mentioning in the chat room, oh, wait, I thought a 568A on one side and a 568B on the other side is crossover. It is not, regardless of what you read. It sort of is and it sort of isn't. But these days, it absolutely is not. That's why, and we'll talk about this, the term 568A and 568B, as we use those terms, are referring to what colors are connecting to what pins. That's it. Has nothing to do with crossover, has nothing to do with straight through, has nothing to do with Ethernet, for that matter. But there is no such thing as connecting 568A to 568B. That doesn't even make sense. You're connecting a certain set of colors to another certain set of colors. That's not what 568A is, and that's not what 568B is. The 568A and B do not define crossover connections, Ethernet connections, or network connections of any kind. They are really talking about where you plug wires into in these connectors. It's talking about colors of wires. It has nothing to do with crossover. So that's why I think a lot of people might get confused over the concept of 568A to 568B. And in fact, 20% of you said, well, sure, because I see that written in books. I see people talk about this like that's what a crossover cable is. Yet, as you can see from this picture, one side is not 568A and the other side is not 568B. If you were to do that, it would not turn out to be this picture. So that's why I always tell people don't focus on A and B as defining some type of pinout for Ethernet. You want to really focus on the Ethernet standard and what the standard says a crossover cable is. And that standard is not written by the folks who wrote the EIA-TIA, which I guess is now the TIA standard. You need to talk to the IEEE, a completely different group who wrote the 802.3 Ethernet standard. Inside of that standard, they tell you what the crossover is. They specify the crossover as part of the standard, which makes sense, I guess, to be able to do that. This wire map, though, make it a little bit bigger here. The confusion, though, with 568A and 568B is understandable, because if you go back in time to when we only had 100 megabit Ethernet, we only used 2 of these pair. We used 4 wires, 1, 2, 3, and 6. And if you only look at those 2 pair on both sides, one thing that coincidentally, perhaps not so coincidentally, but coincidentally, if you were to look at the pinouts from that perspective, one side would coincidentally correlate to the same thing as 568A, and the other side would coincidentally correlate to the same colors that would be used for 568B. So that's where people get that idea that crossover is A on one side and B on the other. Except now we have gigabit Ethernet, which uses all of the pairs, which means we have to cross over all 8 of the wires. And when you do that, you no longer have A and B on both sides, which is why I tell people don't try to qualify crossover in the terms of the colors. You qualify crossover as which pin is connecting to which pin on the other side. That's the important part of this. So that's why I brought up this question, just so that you can kind of focus on that as well. And you'll notice that that is not A on one side, not B on the other side. This is a gigabit crossover cable as defined in the 802.3 standards. However, I'll throw another wrench into this. There are some pictures of this that will cross over 1, 2, 3, and 6, and they'll show 4, 5, 7, and 8 as going straight through, which traditionally we can kind of think of as the older style with only using 2 pair, because those Those other pair in 4 and 5 and 7 and 8 would never be used. But if you try to do that on gigabit, will that work? Could you cross over 1, 2, 3, and 6 and leave 4, 5, 7, and 8 straight through? Well, it's not the standard, but in the testing that I've done just here in my studio with some Ethernet chipsets, that will cross over and work perfectly. With other Ethernet chipsets, it won't. So I think an enterprising chipset creator, somebody who is building the hardware for these Ethernet chipsets, realized, wait a second, we have a lot of people that still have the old style 100 megabit Ethernet, and they're still going to use those. But let's tell our chipset that if it's gigabit, to cross over, use the crossover that's physical, and on those other two pair, cross it over internally. And they do, and it runs at gigabit speeds crossed over, except it's not really crossover cable. How you like that? So yet again, the industry is we have these standards and we have these formats and we have a standard way of doing things, and sometimes they change everything on us and mix it up, and sometimes they're helping us ourselves. What that effectively means with that particular chipset is you plug in any cable, it's going to work great. So that's one of these. So in the chat room, I do have people are even mentioning, no, here's the crossover, except the crossover they're mentioning is 400 megabit. Won't work on gig. So for gigabit, in fact, I've worked with equipment that is gigabit, and I've used a straight through cable to connect those two. This happened to be firewalls, connect those firewalls together, and it would not connect at gig speeds because of a bug in that chipset. You had to use a physical crossover cable, and that's the pinout that you needed, the one that's on the screen right there. So in best case scenario, always use this pinout for a gigabit crossover cable, and you'll have no problems whatsoever. I think that's kind of the takeaway from this. And the takeaway is that it's not 568A and 568B. This was a crossover cable. A loopback plug doesn't have pinouts like this. A loopback plug goes from pin 1 and then loops back into itself into pin 3. So it's almost like having a crossover, except instead of connecting to some other device on this side, the wire goes from 1 and simply loops back into 3. It goes from 2 and loops back into 6. It goes from 4 and loops back into 7, and so on. So look, that's used for a single device. It's obviously not connecting to something else. It's to make sure that what you send out that interface is being received properly by that interface. That loopback plug has a different pinout. We have patch cables. Patch cables are just straight through. A patch cable would be a 1-to-1, 2-to-2, 3-to-3, 4-to-4, and so on. It's just a straight line all the way down the line. So it's not a patch cable. Patch cables and Ethernet cables are effectively the same thing. So that's how that would work. Split pairs. Split pairs when you have the wrong wiring on this, and you are splitting the pairs up so that 1 may go to 3, 2 may end up going to 7. You're splitting the pairs apart. I think I have that description correct. I have a picture of the split pair in my video where, since we're doing this on the fly, I should have just brought that up so you could see it. But split pair is where you have done the pinout incorrectly, which means that I'm the one who's probably done that crimping for you, because I create split pairs all the time. And then I have to cut it, recrimp, and get my pairs right. Split pairs are bad. You should never have them. Crossover cable is the right answer. If you answered B, thank you. Thank you for bearing with my description of that. If you answered B, that is the right answer. Well done. Let's do another question now. Finally, let's do a question that has nothing to do with pictures for you folks listening on the podcast. And the question asks, a system administrator is using SNMP. Which of the following would be the most likely use of this protocol? Is that used to view router statistics, to transfer log files, to encrypt all data between remote sites, to restore from a backup, or to view the desktop of a remote device? A system administrator is using SNMP. Which of the following would be the most likely use of SNMP? Is it to view router statistics, transfer log files, encrypt all data between remote sites, restore from a backup, or view the desktop of a remote device? If you think you know the answer, go to professormesser.com/QA and lock in your answer. Please no answers in the chat room. Please no hints in the chat room. I'm going to see if we can figure this one out all on our own. SNMP, Sierra November Mike Papa. For those of you who can't understand what those letters are that I'm jumbling together over this connection, or you might be listening in a loud area, that might help you a little bit. Sierra November Mike Papa, SNMP, if you're working through that. Yes, folks in the chat room are still talking about the 568A and 568B. And you should never have 568A on one side and 568B on the other side. Or at least you should never describe it as that, because that would be, well, wrong. Should not do that. I look forward to your cards and letters on that one. Someone always sends me something about that whenever we talk about it. Whenever I talk about how there's no such thing as a layer 3 switch, I talk about you shouldn't put 568A and B next to each other. That won't work. You shouldn't do that. There's another one too I talk about all the time, and those are always fun to get those emails because I don't know where to go with that. It's part of the challenges with some of this content too is you will find books that completely contradict the standard. They will tell you the wrong thing. There was a good example of that on Reddit. There's the third one, which is Category 5 cable can't be used for gigabit, except Category 5 and Category 5E are physically identical to each other. They're exactly the same cable. So, of course, it can be used for gig. In fact, the standard says you can use it for gig, and the standard is what is right, 802.3 standard from IEEE. A system administrator, though, is using SNMP. Which of the following would be the most likely use of this protocol? Is it to view router statistics, to transfer log files, to encrypt all data between remote sites, to restore from a backup, or to view the desktop of a remote device? 72% of you believe that it's to view router statistics. 16% say transfer log files. 6% said encrypt all data between remote sites. 4% said view the desktop of a remote device. And 2% said restore from a backup. 72% is a pretty strong number if that's the one that we're really going to go with. SNMP. It stands for the Simple Network Management Protocol. I almost said the words when I was giving you the mnemonics when I was going through the Sierra November Mike Papa. Simple Network Management Protocol. It's quite a useful protocol. We've used it, I don't know, forever. It is designed for network administrators and people managing devices on the network to be able to query those devices and get an answer from them. And there's different versions, of course, you should know about. Just plug all of these into this list so you can see the specifics of this. And the way that it works, you can't see the router that I have up here because my big head's in the way. But you can see that this is my workstation, my network management workstation, because it has a CRT on it. I guess that's how you tell. And where we ask, hey, Mr. Router, we ask in our special SNMP format, which uses a MIB, Management Information Base. If you ever look at the MIB, it's just a bunch of numbers next to it. Now the chat room. We'll talk about why there's no such thing as layer 3 switches in a moment. How many bytes? Maybe we're querying a layer 3 switch, which doesn't actually exist. And we ask that layer 3 switch, how many bytes have gone into that layer 3 switch? And that layer 3 switch using SNMP also responds back to us. So we ask via SNMP, we send messages back via SNMP, the Simple Network Management Protocol. That is commonly used. And usually we're using at least version 2 or version 3. I would think on most networks these days we are using version 3, but I can see that there are other versions. People often use version 2, probably not using a lot of V1. It's just very inefficient in the way that it works. And certainly it's in the clear as version 2 is. So not exactly the most secure set of protocols, which is why most people are using V3 going forward. There's also a functionality in SNMP, I don't talk about it here, called an SNMP trap. I'm doing just SNMP gets here. I'm doing a get, which is asking the device, give me some information. I want to get some information from that device. But there is a method where I could tell my non-existent layer 3 switch, if you see something go a little crazy, if the number of bytes per second suddenly increases, if an interface turns off unexpectedly or turns on unexpectedly, please send me a notice about that. Send me an alert. And we call those, for some reason, traps. That's an SNMP trap. That is kind of an odd name to use, but it's really an alert, a message that is sent to us saying, I know you didn't ask me, but since we decided a long time ago to let you know if anything like this ever happened, I'm going to send you this trap and let you know, hey, this thing just happened. So very useful to know that. Hopefully you're familiar with the SNMP capabilities. And if you see that acronym SNMP, that's what it's referring to. I should have put an answer in here about mail, because some people sometimes mix SNMP up with SMTP, which is the mail transfer protocol, simple mail transfer protocol. Both simple. There was some emphasis on being simple, I guess, back in the day when we created these standards. And it would be, to view the router statistics, 72% of you, absolutely correct. Transferring log files would usually be done with syslog, not SNMP. In fact, we really don't transfer log information using SNMP. It's not a very good method for transferring large amounts of data like log files, whereas syslog is perfectly designed for sending log information back and forth. Encrypting all data between remote sites would commonly be done with IPsec. It would not be done using SNMP. In fact, hopefully you're using version 3 or more of SNMP, where the encryption's built into it. Restoring from a backup, well, that's not SNMP. It's not what you would use for restoring from backups. Restoring from backups usually done with the standard backup utilities using, if you're on Windows, probably SMB, the server message block. If you're an Apple, maybe AFP for Apple File Protocol, AFP. Did I get that right? Probably not. The key, though, the important part of that is that it's using whatever the native file transfer method is for your operating system, and it would not be SNMP. Viewing the desktop of a remote device, an incredibly useful feature. If you're on a help desk, you probably do this all the time. If you have parents, you probably do this all the time. To view the desktop of that remote device, that's usually done using VNC, using RDP, Remote Desktop Protocol. Those are useful to have that there. So that is where you do have to know this. For those of you in the chat room, I think for the A+, that this is one of those protocols you have to know as well, although this is the Network Plus study group. But there is a little bit of overlap between those two. Not a lot, but a little bit. There's, of course, networking is an important part of A+, and obviously a huge part of Network Plus. And interestingly, not completely all of Network Plus is about networking, but most of it is. If you answered view router statistics, answer A, you got that one absolutely right. I have another question for you. This one, since we're talking about standards, this is one where you'll need to know this standard, which asks, which of the following would be most associated with 802.1x? Would that be multiple VLANs between switches? Would it be a loop prevention on a switched network? Would it be a radius server? Would it be redundant storage? Or would it be an encrypted tunnel? This one's a little bit more difficult. Which of the following would be most associated with 802.1x? Is that multiple VLANs between switches? Is it loop prevention on a switch network? Is it a radius server? Is it redundant storage? Or is it an encrypted tunnel? If you think you know the answer, go to professormesser.com/QA and lock in your answer. This is one whenever I start looking through all of these questions that come in. This one probably is more difficult than the others because you have to take an extra step. And I like to do questions like this where there's an extra step involved to get to those. This one absolutely is an extra step. And it's one that is, I'm not going to give you any more information. I was going to give you a hint, but I'm not going to because I like this one. I like this question. I think this is one that makes you think. In this question, you have to know technologies that are not necessarily part of the question. So that I think is an important consideration for the exam, because a lot of the questions on the exam they don't give you trivia questions. They don't ask you, what does SNMP stand for? Is that Simple Network Management Protocol, Simple Network Mic Protocol, Simple November Mic Protocol? They don't ask you questions like that. That's way too easy. Those are flashcard questions that they don't ask you on the exam, trivia questions like that. Instead, they ask you questions like this, where you have to understand the underlying technology to be able to answer the question. And in my mind, these are better questions. They really are asking you very specific information about this particular question and working through them. So hopefully you'll be more familiar with working through those. I think whenever I start looking at the options available, maybe there's some of these where you can kind of break down the differences between the answers, and maybe some of them you can throw out immediately. Some of those answers should jump out at you and go, wait a second, I know what that is, and that's not 802.1x. Maybe you got to that point. Let's see if you did. Not as many people answering this one so quick. There's a lot of people Googling 802.1x right now, and you aren't getting an answer very easily when you do that. So that is one of those where when you get into that, it's one of those situations. Let's see how you did. Which of the following would be most associated with 802.1x? Notice it's a capital X. It's a pet peeve, I'm sorry. Multiple VLANs between switches, loop prevention on a switch network, radius server, redundant storage, or encrypted tunnel. Which one is it? 51% of us say it's radius server. 24% of us say that's for multiple VLANs between switches. 17% said encrypted tunnel. So that's a pretty good mix. Those top three almost covered everything, because it's really 8% said loop prevention on a switch network, which I think people have understood maybe that's not what that is. And then 1% said redundant storage, which is definitely not what that is. On your Network Plus, we talk mostly about 802.1x as it's associated with wireless networking. But the reality is 802.1x applies both to wired and wireless networks. But for this one, I'll step you through the idea of why 802.1x is the context here. Whenever you connect to a wireless network, and it may not even have a password associated with it, it's wide open, and anybody can connect to this network. Maybe it's in a coffee shop, and they don't even put up any type of a password or anything to get in. They just say, connect to the wireless network. The name is coffee, and you can connect to the network. But that also means there's no encryption on that network. But you can get in without any special password, which is kind of nice. Not what you should do, though. I say kind of nice and convenient, but kind of nice for the hacker, because now they can see everything you're sending over the network. Not a great situation. WPA3 is going to be so nice for that. Whenever you see this on your wireless access point, you might have an option for setting a password that you can share with everyone. This is called a pre-shared key, a PSK. You'll sometimes see this written as, sometimes it's written as personal, a personal connection. If this is WPA2 listed here, if you have one of the newer access points, it probably says WPA3 PSK, because you can still do that with WPA3. But that means you have to hand out the password. And if you're in that coffee shop and they're doing this, they may say the wireless network is coffee. The special code word you need to know is coffee1. And then you have access to the network. Again, not a fantastic way to manage security, but it's better than just being open. But our question was about 802.1x. If you're on a network that is in your office, remember when we used to go to an office? When you go back to your office, you will connect to the wireless network. It will prompt you for your login, your network login. It's not going to ask you for a pre-shared key. It's going to ask you for your username and your password, authentication details that are specific to you that nobody else has. This is great, by the way, because if a new person gets hired and you add them into the master database, then suddenly they can use their username and password to access the wireless network. And if they are not part of the organization any longer, they decide to leave or go to a different department, they get removed from the database, and now they can no longer log into the wireless network. That's a great way to manage your security. 802.1x is a network authentication standard. This NAC configuration usually is configured to communicate with some master database on the back end. This could be an LDAP database, which is very common if you are running Microsoft Windows Active Directory. That's an LDAP database. You might have a third-party database. Maybe it's one from Cisco, so you're using a TACAX database for that. Or you might be using something that's much more common, like a Radius database. The one that you're probably using in your environment is the one that you were probably already using. So if you were and if you're an organization that's Microsoft Windows, you're probably using LDAP. You're not going to use TACAX or Radius because Microsoft Active Directory has an LDAP front end. You can talk directly to it via LDAP. But if you don't have Microsoft Active Directory or you don't want to authenticate with that, you may set up a Radius. There are a number of free Radius servers that you could start up right now. There's one appropriately called Free Radius, where you can connect up all these Radius connections and put in your own username and password, tell your wireless access point, authenticate everybody to the network to this free Radius database, and now nobody can get on the network unless they have their username and password. There's nothing to share, and you don't have to worry about that password getting out. A great way to do it. Notice it's a capital X. As a little bit of trivia, anything that's a capital letter is a standalone standard from the IEEE. Anything that's a lowercase letter is an addendum to an existing standard. So, for instance, 802.11 is the wireless standard. 802.11a, b, g, n, ac, and the others are all changes or updates to that standard. And in fact, usually there'll be a number of years go by and they sort of encapsulate all the previous standards and come out with a new version to kind of follow all of those. But when you see a capital letter, what they're really saying is this is a standalone standard. It doesn't stand for another letter. It's not like 802.1x. The X could be an A or the X could be a 1. No, that's not what that means. It's not a variable. You're not in your math class. This is not algebra. That X is an actual capital letter X. And that's what that stands for. So that's why the answer here would be a Radius server. If we're using 802.1x, we need some type of server on the back end to provide the authentication. This could have said TACAX server. This could have said LDAP server, but it is a Radius server. That's what that is. So 51% of you went down that road. You did the steps you needed to do to get to that point. You got that one absolutely right. Well done. We've got multiple VLANs between switches. A different standard, 802.1q. is that standard, a completely different standard. It sounds very similar. It's a different letter. 802.1q is the trunking standard for VLANs, have multiple VLANs between switches over a single cable or group of cables. So that would not be the right answer, although it's close, but not quite there. Loop prevention on a switch network would be STP, the spanning tree protocol, definitely not 802.1x. An encrypted tunnel, probably using IPsec or one of the other many ways to do an encrypted tunnel, but 802.1x is not an encrypted tunnel. So that is not what we would normally associate with 802.1x. And redundant storage, I had to put something there, right? And only 1% of you even thought that was the case. Was not correct from those. So absolutely knowing that 802.1x has to do with authentication, then you would need to know there's some type of authentication server required. And of course, that's how we got to that answer. So if you answered C, Radius server, you got that one absolutely right. If you are watching this video for continuing education credit, I would be glad to send you an email that gives you a certified message back that says, I certify that you watched this video, and I even provide a digital signature, and I attach the digital signature to the email, but you have to follow these steps. Go to the top or the bottom of the Professor Messer website, click the Contact Us link. In that Contact Us link, put your name, your email address. In the subject line, please put that this is the February 2021 Network Plus Study Group. And in the body of the message on a line all by itself, put the super secret code word of 802.1q. See what I did there? 802.1q is the super secret code word of the month. And then if you'd like to put anything else in that message underneath that line that's all by itself, you're more than welcome to do that. I read through every single one of these you send me. I'm not able to personally answer back every single one of them because I get hundreds of these messages every month, but I am more than happy to read through them, and I enjoy reading through them. So if you'd like to put anything else in there, you're more than welcome. If you don't want to put anything else in there, that's fine too. I will still send you back an email, but it helps me check it. If it's right there at the top, I can go through them very quickly and get them off to you. The super secret code word of the month, 802.1 Q. Not what you might think. So make sure you get that right. I want you to be sure you get that to me. There's so much information in this exam. It is just an enormous exam to have to deal with. There are topics that are covered, from subnetting, the cables we looked at, protocols, all kinds of different things. What I've done is take all of this information, put it into a single set of course notes. This is my course notes. You can kind of see it right there. Looks just like that picture. It's on the screen. Everything from every video. And that's a lot of videos, 101 videos, 12 hours of content. If I look at how many pages this is, did I not put the number of pages? It's big. So in here, number of pages, 66 pages of notes. That doesn't count the introduction or table of contents. That's 66 pages of notes. It is an enormous document. I have a picture of it. Here it is. I have the document. This is the PDF. So if you wanted to go through and look at this PDF, I break down every single video, all of the text, all of the important graphics, all of those charts, all of those diagrams from my course. They are in these course notes. I'm going to fast forward through the course notes. For example, connector types. There they are. So if you need some help understanding those copper connectors or fiber connectors, there they are. So they are in the course notes. It's also another great way to support the website. This is kind of how we keep the lights on. So if you enjoy the live events, you enjoy the videos, you get your certification, or you need something to help you study for your certification that's consolidated, that everything is in one place, this can really help you as well. You can find out more about that at professormesser.com/NPCN. That stands for Network Plus Course Notes. For those of you that have already purchased the course notes, thank you so much. It really does go a long way to keep this crazy experiment going. And for those of you that are considering it, please stop by and have a look at that at professormesser.com/NPCN. I know we're coming up. I talked a lot, so let's do another question before we run out of time here. This next question asks, if I can get it up on my screen so I can go along with you. There we go. A network administrator would like to confirm that all application traffic is using encrypted protocols. I think that's a pretty good idea. Which of the following would be the best choice for this task? Would it be a port scanner, trace route, protocol analyzer, toner probe, or spectrum analyzer? A network administrator would like to confirm that all application traffic is using encrypted protocols. Which of the following would be the best choice for this task? Is it a port scanner, trace route, protocol analyzer, toner probe, or spectrum analyzer? If you think you know the answer, go to professormesser.com/QA and lock in your answers. See if you happen to know what it is. That might be useful to be able to know these different options. Remember, no answers in the chat room, no hints in the chat room. We'll figure out the details of this together. Lock it in at professormesser.com/QA. I do have some question answer that you can use with Network Plus that is on my website. Go to professormesser.com/take10 or follow the links in the Network Plus pull down that have some free questions for you for Network Plus. Might help you. So if you want some of those can absolutely help you with what you are doing. I think a number of people think they know what this one is. I always see the numbers. When the numbers go up very quickly, I think maybe people are tuned into this question. They know what they would use to be able to make this happen. So this is what you would use to be able to make that happen. Let's see if you know. Let's see how you do with this one. A network administrator would like to confirm that all application traffic is using encrypted protocols. Which of the following would be the best choice for this task? Would it be a port scanner, trace route, protocol analyzer, toner probe, or spectrum analyzer? 74% say you would use a protocol analyzer, but 20% say you would use a port scanner. 3% said spectrum analyzer, 2% said trace route, and 1% said toner probe for this. 74% is pretty strong. That's a pretty strong number. A protocol analyzer, and as someone who used to be a systems engineer for a protocol analyzer company, I would tell you that this is a great way to see exactly what's going over the network. You can not only see conversations about that, but you know absolutely if it is sending traffic in the clear, if it's sending traffic that is encrypted. You can view all the traffic going over the network. You can look at the efficiency of the file transfers. You can understand if any errors are occurring with the application. You can understand if errors are occurring with the network. Protocol analyzers see everything. They are the ultimate answer whenever somebody says, is something going on in the network? And you need to know, well, is there something going on in the network, or is it something with the application? The best and only way to really know is to have a protocol analyzer. The one I have on the screen here is Wireshark, but any protocol analyzer will work. This is probably the thing that we always hear the most from whenever we're talking to tech support and we're having a problem like this, and they say, do you have a packet capture? Because we can just look through the packet capture and we'll know immediately what the answer is. And more often than not, people go, nope, I don't have one. That's why I called. So what is it? Is it the network or the application? We don't know. We need a packet capture. So if you have a way to do it through Wireshark, that's a great way to get a packet capture. Sometimes you're working with a firewall or a router or another third-party device that can capture packets internally to that device. That's a great way to do it as well. So packet captures are easily done with a protocol analyzer, and it's a great way to see everything on the network. You see everything on the network. Nothing gets by you. So if you ever need to confirm, are we really seeing encrypted protocols on the network? This is what you would use by far. This is the best way to do it. Protocol analyzer, absolutely. Now, 19% of you, 20% said port scanner is what you would use. Port scanner, incredibly useful functionality, but it is one where it interactively will tell you on a device, are there ports open and available to use with a particular application? It does not tell you if those ports are going to send encrypted or non-encrypted data. Sometimes you can assume that from the port number that is in use, but it is very easy to be able to connect and set up a web server to send non-encrypted data over port 443. So that's one of those situations where if you're ever in the business of trying to figure out, is it really sending encrypted data? Port scanner's not going to tell you. You have to see the data on the network to really know. We also have Spectrum Analyzer, which is great for showing us the spectrum, specifically in most cases, the wireless spectrum. That's how we would use these. But a Spectrum Analyzer is not really going to help you understand if the data using that spectrum happens to be encrypted or not encrypted. So that's another one of those situations. 2% said trace route. Trace route, very useful for knowing what the routes are, what routers are between you and another device. That doesn't tell you anything about application traffic or if that traffic is encrypted or not. And a toner probe is when you're trying to find, you have one end of a cable, and you're trying to find the other end of the cable. And if you've ever been in a data center or wiring closet, there's hundreds and hundreds of cables in there. How can you find the one cable on the floor and figure out where that one cable is plugged in the wiring closet? It's a toner probe, which is really a combination of terms. There's a toner that you put on one end that sends a tone through the cable, and then there's an inductive probe you use on the other end to be able to listen in and hear the tone that you put on the cable. So that's really a sort of a conglomeration of two different things that we stuck into one, and we just call it a toner probe because that's what it is. Quite literally, a toner probe. If you answered protocol analyzer, you got that one absolutely right. Now, since I was talking so much on this one, I'll give you one more question. This one is one of those situations where if you have been paying attention throughout the study group, this might be a gimme. Let's find out if it is or not. This question asks, which of the following would be the best way to prevent loops between switches? Which of the following would be the best way to prevent loops between switches? Is it RSTP, 802.1x, route poisoning, TACAX Plus, or split horizon? Which of the following would be the best way to prevent loops between switches? Would that be RSTP, 802.1x, route poisoning, TACAX Plus, or split horizon? Which one is it? It's got to be one of those, right? If you think you know what it is, lock in your answer at professormesser.com/QA, and you will have that answer locked in. You'll be able to know exactly whether you answered it or not in just a moment when we go through all of those. It becomes useful to know those answers. professormesser.com/QA, lock it in. Preventing loops between switches. What would it be? How would that work? How would we make that happen? It's got to be one of these, right? It would be useful to know this. And let me put the answers up for those of you answering again. RSTP, 802.1x, route poisoning, TACAX Plus, or split horizon. It's got to be one of those. See if you happen to know. But why isn't a layer 3 switch a real thing? We'll talk about that in the after show in just a moment. Why is that not real? Why? Where did that come from? Why is he saying that? Clearly, you've seen a layer 3 switch. You can Google and find a layer 3 switch, and yet I'm saying it's not a real thing. I'll tell you why in just a moment. I'm being a little bit facetious. I'm being a little sarcastic when I say that, but it actually is not a real thing. We'll talk about that in the after show. Let's see how you did with this one. Which of the following would be the best way to prevent loops between switches? 78% of you say it's RSTP. And then single digits for everything else. Is it split horizon? 9%. We have 802.1x and TACAX Plus at 5% apiece. Really? We just talked about 802.1x. 3% of you said route poisoning. So 78% said RSTP. Now, immediately, I would think spanning tree protocol would be the right answer here. But of course, if you're connecting a real modern device, really recently modern device, you're using the rapid version of spanning tree protocol, RSTP. That is, you can see the standard 802.1W, which is obviously an update to the 802.1 standard because it's lowercase. The STP, the reason it's rapid spanning tree protocol is because with the original spanning tree protocol, you plug in a device and it could take 30 seconds for that device to connect to the network. And then today, people would try to do that and they'd call the help desk because it's not connecting to the network. They would be on the phone with the help desk before the device even connects. That's almost a lifetime. It can take up to 50 seconds with spanning tree protocol because it has to do a lot of checks with spanning tree protocol. Well, that's too long. We don't have time for that. So we created an updated version of spanning tree protocol that worked much faster, and the most you would ever see is 6 seconds, which you don't even realize went by as you're connecting. It is backwards compatible, though, with 802.1D, which is an actual standard, because it's an uppercase. I know. They really didn't do themselves any favors by making the uppercase, lowercase thing, did they? Not really helpful, folks at IEEE. It's a bunch of engineers. What do you expect? That's like saying to a bunch of accountants, can you make the process of doing our taxes easier? They're like, what are you talking about? It's so easy now. Okay, that's that situation. RSTP, rapid spanning tree protocol, is exactly what you would use. And the 78% of you said, yep, that's what I would use as well. 802.1x, come on, people. We just talked about this. That is used for authentication on your wired or wireless networks so that you don't have to use shared passwords. And you would use that with what? Radius, TACAX, LDAP? That's right. That's what 802.1x is. Route poisoning is a useful way to prevent routes from being propagated into other routes. This is obviously with a dynamic routing protocol. But routes have nothing to do with loops between switches. This is layer 2. Route poisoning is layer 3. And near the twain shall meet. TACAX Plus is one of those authentication systems that you might use, a AAA server. So TACAX Plus, Radius, LDAP, we just talked about this. I was here, right? Was I here? Were we on? Was this live? It was. So it would not be TACAX Plus. Split Horizon is a way that you can modify what routes are advertised and what routes are not advertised to a system. If you're at home these days, we have a lot of people on VPN. And so some VPNs, when you connect to it, will send 100% of all traffic through the VPN. But what if you wanted to print to a local printer that's in your home? There's no way to go through the VPN. You have to disconnect the VPN, print to your local printer, and then reconnect to your VPN. So one of the things we could do is have a split horizon where some of the traffic that needs to go to corporate will go to corporate. But if it's something that's on your local network, it will still print locally. And that way, all of the traffic is going the right place. So split horizon is nothing to do with loops between switches and everything to do with routes and being able to make all of that work. That is the right answer for you. Answer A, the rapid spanning tree protocol. 78% of you got that rapid spanning tree protocol absolutely correct. That is the right answer. That's the one you should use, and that's the one most of you chose. So well done with that. We do one of these study groups every month, and we go through the objectives to determine what questions to ask. And that's what you should be doing as well. If you don't have a copy of the objectives, it's probably the best study materials you can get, and it's free from CompTIA. Go to professormesser.com/objectives, and you can, of course, download these. There's a link to take you over to the CompTIA website, or go to the Google machine. Just type in CompTIA exam objectives. It will take you right there, and you'll be able to find those. It is a comprehensive list of what's on the exam. People ask me all the time, what should I really be studying for this exam? You should study everything, the exam objectives, which is why, by the way, all of my videos are directly associated with the numbering scheme and topics from the exam objectives. I use it as my checklist when I make the videos. I use it as my checklist when I make my course notes. So I don't deviate from that list unless there's a good reason to, and usually there isn't, because CompTIA stays pretty close to those. Make sure you get your copy of those. We do one of these study groups every month. Next month is kind of weird with the scheduling. So we have a Security Plus study group tomorrow. I never do these back to back. So what are we doing tomorrow? We're doing another study group. And then next week, the first week of March, we have 2 study groups then as well, A+ study groups on the 2nd and the 4th. Our next Network Plus study group on the 25th of March. Kind of skip a couple weeks there. Sorry about that. And then a Security Plus study group on the 30th. I just have a weird schedule for March for some reason. So I appreciate you bearing with me. These dates can change. These dates often change. So please always check back with the calendar. You can find that at professormesser.com/calendar. You can also add my Google Calendar to your calendar. And if I ever change this, it moves in my Google Calendar and then it updates in your calendar automatically. That might be an easy way to do it. Well, that is our hour and 10 minutes of Q&A. We got a little extra today because I talk so much. But stick around. We have an after show after this. Well, I will explain to everybody why there's no such thing as a layer 3 switch. Again, I will explain that. Don't forget about the Success Bundle on our website at professormesser.com/netsuccess. And of course, you've got all the freebies that you can get anytime you'd like at professormesser.com/YouTube, professormesser.com/Twitter, professormesser.com/Instagram. If you liked what we did this first hour, I would love it if you click the like button in YouTube. This really does help when we talk to our friends back at the YouTube headquarters, and they're trying to see, do people really like what you're doing? They don't seem to be clicking the thumbs up. Although if you didn't like it, I guess click the thumbs down. I would prefer if you didn't like it to also click the thumbs up. I think you win either way. I think you're able to vote and you feel good about that, and it helps me in both situations. Thanks for being here. Thanks for joining us for the Q&A. Stick around for the after show, and we'll see you next time on the Network Plus Study Group. I know it's all thumbs up, isn't it? Or is that what they're doing? Or did they get rid of the button entirely? Which I'm just waiting for. What do we need one of those buttons for? We'll just get rid of them. If you'll bear with me a moment, I'm going to start up the phone lines. There's nobody here but me, so it takes me a moment, but I've already got them ready to go. I just click a few buttons on this side. I host a show. It's on the cloud. It's out cloud-based, which means it must work perfectly if it's all cloud-based. I'll click a few buttons. This is going to make some noises on our end, and it's going to say,
"Thank you for..."
Well, you're welcome. And for those of you that joined us earlier in the week, I updated my credit card, so it's not going to hang up on you now.
Enter your 6-digit PIN.
I'll be glad to do that. We'll put in our 6-digit PIN. And if I put that in right, the nice lady says,
"Welcome, Professor Messer."
Thanks, nice lady. It's nice of you to say. I know, I am recording. That's right. So now we can get all of this going. Now you can call in if you would like to. In the continental United States, it's a toll-free number, 855-785-RJ45. That is the phone number. West of the Rockies, 855-785-7545. And it's the number that's on the screen. Where is it? It's right there. Right here. That's the number. The number is also, because it's toll-free, can be called for free from anywhere in the world. You can just use Skype because Skype doesn't require any login or any minutes or any payment for that. You go to ProfessorMesser.com. No, I don't have a link to there yet. You just have to go to Skype and type it in, but you have to put a +1 at the beginning. You have to put that piece at the very beginning. +1, that's the country code. +1 855-785-7545. I need to put a link on my site that will open Skype and just call the number. I got to remind myself, Lori, she's watching the replay. Make sure I do that. So she's the one that writes these things down to be able to do that. Before we go to the phone lines, I promised you I would tell you why there's no such thing as a layer 3 switch. And the quick answer is because there's no such thing as a layer 2 router. Whenever we talk about layer 3 switches, it's a term that was created by marketing professionals. It used to be all we had was switches, which of course make forwarding decisions based on the destination MAC address of the traffic that's going through it. It's a very smart way to forward traffic around your network. Very efficient, very easy to do, fantastic, very fast. And we all plugged in these switches. But in most cases, we had a switch that was switching all of our people. And then we had a router where we were routing between different subnets. Maybe we were routing to subnets at a different site even. And we thought, why do I have two pieces of equipment? It would be nice if I just have one box where I can use one power connection and only have to deal with one operating system and only have to deal with upgrading one device, and it uses less room in my rack. There's a lot of good reasons to combine these things together. And so companies started doing that. They started taking switch functionality and router functionality from two devices, and they pushed it into one chassis. So you've now got one box that does everything. But we just couldn't call it a switch anymore, and you couldn't call it a router anymore. I know. We'll call it a layer 3 switch, because it is a switch that switches, but it's still switching at layer 2. And there is a layer 3 component, but that's a router, and it's routing at layer 3. So that's what it is. It sort of took those two terms and kind of squished them together to make a new term that made no sense whatsoever, because the switching isn't occurring at layer 3 and the routing isn't occurring at layer 2. Why are we calling it layer 3 switch if there's no such thing as layer 3 switching? You see what I mean? And in fact, if you look at the configuration on those devices, the switching part is still in its own world, doing its own switching thing, all at layer 2. There's a completely different set of configurations that are all doing the routing, as if it was two independent boxes, all just sort of stuck into the same physical chassis. That's what that's about. So that's why we call it a layer 3 switch, and I jokingly do say there's no such thing as a layer 3 switch, when very obviously there is, because we're now calling it that. But it doesn't really make any sense. That we just made up a name and we're calling it that, and it doesn't even mean that. What we did it. Is it as effective, though? Is a layer 3 switch useful? Well, absolutely. It's pretty effective. Now, many people will tell you in networking, in security, and sort of IT in general, that in the best possible world, you purchase a device to do one thing well. So you should let the switches switch. You should let the routers route. You should let the firewalls firewall. And you should not be pushing all of these things into one device. That it doesn't make sense. However, especially as time has gone by and technology has improved, a lot of these functions are now occurring in hardware. They're all very efficient. They're all incredibly flexible. Our next generation firewalls are incredibly competent routers on par with a standalone router. Are there advantages to having a standalone router? Yes, there are. Can you pretty much do everything you need in a device that is a router /firewall/switch? Yes, you can. You can do that as well. So the technology has really changed since those days. There may still be a lot of very good reasons to let your switch and your router route and your firewall. Absolutely. But in many environments, like the one I have in my studio, having a device that does everything all in one greatly simplifies things for me. So it just depends on sort of what you're doing. I have run into situations, though, especially with these devices made at home, where it's a wireless router and it's my cable modem and it's a router inside of it. It's got a switch inside of it, switch ports in the back. It does voice over IP, and it has electrical connections on the back so that I can plug in and have all of every component powered off of that device as well. So having all of that in one device becomes useful until the point where I want to do something interesting with some static routes, and then you suddenly realize the operating system of that device doesn't allow static routing. Or maybe you've plugged in way too many devices, and now your PoE connection now is overloaded. You do run into those situations. So it's really up to you as to whether it makes sense. You do have to look at the fine details. You have to look at the configuration settings of this. You have to make sure that if you are using this device, that it has enough memory to handle the size of the routing tables you use, that it really is doing its switching and hardware, that it really does have the ability to handle the dynamic routes you would want to handle. But most of these days they do. Most of these days they do a very good job of being able to make that happen. So that does become useful to have that there. More questions in the chat room. Let me come back to one. I just had a very good one show up about Resource Monitor. We'll come back to that in just a moment. There was a question earlier about whether 802.11ac, the wireless standard, supports 2.4 gigahertz or 5 gigahertz or both. Because if you notice from my materials, everything is 5 gigahertz. 802.11ac actually is only a 5 gigahertz technology. But wait, I have an 802.11ac router in my house, a wireless router, and it will operate on 5 gigahertz and 2.4 gigahertz. Answer that, Mr. Smart Guy. And that's actually confusing, isn't it? Because if the 802.11ac standard clearly says this only works on 5 gigahertz, let's be more specific. Where's the 2.4 coming from? Well, if you look into the details of the technology, you'll notice the 2.4 gigahertz technology, everything running at 2.4 gigahertz is actually running at 802.11n. It's actually running at the technology, the last technology we used that had 2.4 gigahertz functionality. So that's why. So confusing with that, isn't it? Because I thought we were buying an 802.11ac device. It should all be 5 gigahertz, and yet there's some functionality. And it's actually useful to have that because I do have devices on my network that are not in devices or that are not AC devices. They don't operate at 5 gigahertz, but I still need to connect them. Especially a lot of IoT devices. I've got doorbells and cameras and garage door openers and that kind of thing. And they don't operate at 5 gigahertz frequencies. They're kind of old. I need to upgrade them. So having that 2.4 gigahertz, effectively an 802.11n modem inside of this device does allow me that backwards compatibility. So that's where that comes from. That's why I mention in my videos that if you are seeing 2.4 gigahertz on your AC device, it's actually running in. So that's what that is about. And as I'm slowly upgrading, I'm upgrading my wireless printers and wireless doorbells and that kind of thing. We will move to 5 gigahertz. But that is the situation you find yourself in, is being able to do that. When 5 gigahertz frequencies fill up, where will we go next? Well, we got a long time before we have to worry about that. If anything, we're doing much better at optimizing the bandwidths we have, and the 5 gigahertz range is so big. I don't know if you saw we've got those video, the images. I think I have it in my course notes. How convenient that I've got my course notes here. that we could pull up the frequency table for wireless networks. I'll pull it up so you can see it here. We'll talk about this in just a moment. So this is really why 5 gigahertz is where you should be moving in this. This is from section 1.6, wireless network technologies. So the 2.4 gigahertz spectrum, each one of these blocks is effectively a 20 megahertz block. It's 20 megahertz of bandwidth in the wireless spectrum. And unlike a piece of copper where everything in the copper is ours to use, with wireless, it's not that way. With wireless, there are only certain frequencies you can communicate on. And for 2.4 gigahertz, you can communicate in the United States between 2.412 and 2.482 megahertz. That's about it. There's a little bit difference in there, but that's pretty close. So that's the size of these 20 megahertz blocks. Well, for 5 gigahertz, look at all the 20 megahertz blocks you have. What a difference. So if you're in a situation where you're in a very busy apartment building, maybe there's a lot of houses around you, you just can't find a good signal on 2.4 gigahertz, maybe you should be moving to 5. Because not only do you have more bandwidth, more frequencies to be able to put your traffic on, but now you can start using these frequencies together. You can have 40 megahertz channels, 80 megahertz channels. In the case of 802.11ac, you can have 160 megahertz channels and be able to have an enormous amount of bandwidth available, which means we can go even faster with more devices on our network. The more bandwidth we have, the more information we can send at the same time. So are we going to fill that up? I guess eventually we will, right? So where do we go from there if we fill up that technology? Well, I don't think we have to worry too much about that yet. What we've done in the past, and you can kind of see it on this view, is we started with one tiny set of frequencies, and then we kind of got rid of whatever was on the frequency and carved it out for this wireless functionality. And so all of this was not available on day one. We've been adding to it. The Uni 2, Uni 3, we've been adding and adding and adding and adding as we go to create even more frequencies that are available. So I guess we could still start doing that. You could see that some of these were only indoor channels. They were usable outdoors after April 2014. Then we added some new channels in 2014. Anything that's red, we can't use yet. So there is some channels that maybe we could start to use. Maybe we can push something off to somewhere else. It's complicated because, as I mentioned, once you install equipment, it sits there a very long time. And it would be awful if suddenly you're in a situation where you've installed some equipment that uses these channels, and suddenly the FCC in the United States, it's the Federal Communications Commission that manages this, the FCC shows up and says, guess what? You can't use those frequencies any longer. You got to move those somewhere else. This happened very early on with people that had wireless microphones. If you were in the speaking world where you were doing speeches, there were all these wireless microphones. FCC came out and said, we're moving you off to a different set of frequencies. You need to buy or upgrade to new microphones that use different frequencies. That's one of the reasons why they're always moving things around. So they could still do that, I guess. They can keep making that happen for all of that. Another question from the chat room. PoE defeats the Fox and Hounds or toner probe. What do you do when you find a cable at the other end when it's charged with PoE? That doesn't necessarily defeat it. Putting an analog signal on a cable can be done on PoE as well. And quite honestly, the PoE is often done at the switch. I guess if you're trying to find the switch side and all you have is the other side, that's a little different. But putting an analog signal on a wire is not going to be... you're not going to have a problem doing that with a toner probe. Toner and probe is such a basic technology. We are putting an analog tone on a set of wires, and then on the other side, we're simply listening. We're using an inductive probe. It's not even touching the copper to just listen in. It's like using an AM radio to try to find that signal. It's so simple to do that the PoE, the power over Ethernet's not going to discount that. It works just fine. In fact, that's what I have here. I have a lot of PoE in my studio setup, my PoE is connected to primarily cameras. So I'm watching you. Do not come to my studio because I'm watching you. And that way I can see everything going on outside, and it's all, I don't have to run extra power for that. It's all PoE. Easy to have that there. Now the type of connection I have there, I don't usually have to do a toner probe for that though. But that having a different type of toner probe that is just sending that analog signal should be able to work just fine on PoE. Makes it a lot easier if you're trying to find the end of that cable though. And I do have a similar problem with that because I do have connections between buildings sometimes. And I've got groupings of cables, and sometimes it's hard to find that cable. So useful to have that there. Other questions in the chat room. It's not on the exam. You're right. It's not on the exam. The new Ethernet standards, Wi-Fi 6, WPA3, those types of standards are relatively new. They're not on the existing Network Plus exam. Some of it is on the newer Security Plus exam, and I do talk about more of the security side of things, especially as it relates to WPA3 there. So we're not quite ready to talk about 802.11 version 6, Wi-Fi 6, whatever we're going to decide to call it. Maybe we'll call it AX. I don't know what we'll end up calling it. But the standard is not one you have to worry about for the current N10-007, fortunately. Now, CompTIA has said we will introduce the N10-008 in September of this year. So there will be a new version showing up here eventually. The interesting part about that is your current version, the N10-007, still sticks around usually about 6 months after that. And that's why I said that you will still have this exam available for you to take until probably March of next year. So well over a year from now to be able to do that. Kind of makes sense to me. Other questions in the chat room. Can I explain why power doubles every 3 dB? The idea and how we measure decibels is kind of a weird one. The decibels, the bells, the tenth of a bell, and the way we do it is a logarithmic scale. So it's not a linear scale. We're so used to the scale, like if you go from 1 to 2, you've just doubled it. If you go to 2 to 4, you've just doubled it. Well, why does that work? Because if it's a logarithmic scale with decibels, we just measure that doubling in a different way. And with decibels, 3 dB is a doubling. So that it's just a different way to view the way the power is being allocated. I guess minus 3 dB means we're losing half of the signal. So it depends on which way, of course, you're looking at the signal gain or the signal loss. It is kind of weird to do it that way when we work with powers of 10 and powers of 2 with computers. Suddenly we're working with these decibels, but it makes sense for signal strength because we've always done it that way. I won't say it makes sense to do it because it makes sense. It makes sense to do it that way because that's the way we've always done it. So most people understand that that's how we measure things in that format. But that's why it is a logarithmic scale to be able to work that way. And that's why I put the chart. I think I put the chart in, I think in the latest version of the Network Plus, it's still in there, where we talk about power, especially as you're splitting a cable. So if you put a splitter on a cable modem, for example, most of the splitters will split 50-50. And if you look at them, they say loss of 3 dB here and a loss of 3 dB here because you're cutting the signal in half. And that's why that 3 dB keeps showing up everywhere you go. Makes sense to have that there. Yeah, the reason they did the Wi-Fi 6, this is something the poor Wi-Fi folks have really struggled with from the very beginning, is these are incredibly knowledgeable engineers. They have created technologies that have changed the industry from a networking perspective. Wireless networking was an incredible boon. It is incredibly valuable technology. We use it everywhere, and they've done phenomenally at building out our wireless network technologies. Not great marketing people. They've tried really hard to figure out how to market, and they started with Wi-Fi because they figure, well, if you have audio, you know about hi-fis. Nobody knows about hi-fi. Nobody who's younger than me understands what I'm talking about with a hi-fi. High fidelity is what you would describe the older systems that played records. So they said, I know what we'll do. We'll give it a hip term that makes people think about the ease of using records, and we'll call it Wi-Fi. That really is sort of the idea behind this. I realize there's more to it than that, but they came out with the Wi-Fi, and we're like, Wi-Fi? That doesn't even make sense. Does that make sense? No, that doesn't make any sense. What? But we went with it. So they said, okay, but wait, there's other protocols involved, like WEP, wired equivalent privacy. WEP, wired equivalent privacy. What are you talking about? Where did that come from? That doesn't even, you mean it's equivalent as wire? What are you trying to say with that? It's almost like they took a standard name that they wanted to use and they sort of back engineered a term for it. It didn't make any sense, but it made sense in its own. Why they just didn't call it, here's what we call it. It's WEP, it's WPA, it's WPA2. On its own, we're fine with that. Networking people are very used to dealing with acronyms, as you have very well seen. So that's why it's sort of a challenge. But now they realize, wow, everybody's bought this. Everybody has one in their home. Trying to explain to a consumer in Best Buy the differences between 802.11n and 802.11ac. I don't even know what you're talking about. N and AC, why is it not version 1, version 2, and version 3? You know, if we're going to talk versions, that makes sense. So they finally decided, you know what, we need to consumerize this a little bit. This is effectively the 6th version of wireless technology that we have released as a standard, as a broad standard. So let's call it Wi-Fi 6, which to me makes a lot more sense. Why didn't we start it with Wi-Fi 1, Wi-Fi 2, Wi-Fi? You know why? Because the engineers would have called it, well, it's not really 1. We should call it .8. It's Wi-Fi .8, maybe .8 prime. They would mess that up too. Finally, they've got it Wi-Fi 6. I think Wi-Fi 6 makes sense. So we're going to go with Wi-Fi 6. We'll see how that works. They may abandon ship. We may never get to Wi-Fi 7. Maybe called something completely different then. But, you know, we sort of struggled this with operating systems. It's Windows 95. Well, now it's later in the years. 98. It's Windows 2000. And then we realized this just doesn't scale. This is not really describing the product. All right, Windows 7, because it's the 7th one. Well, it kind of made more sense. And I think they started to see, all right, Windows 8. So, of course, Windows 9. What? Oh, I mean 10. Okay, 10. Well, it wasn't perfect, but they got to 10. Now, the problem, of course, just like Apple, is 10's a good number. We are never coming off of 10. We're always going to be 10. It's OS 10. It's Windows 10. It will never be 11. I'm predicting this now. Never in the history of ever will we move from 10. Will we? Will it be 10X? Will it be 100? Windows Infinity? Windows 360? We'll see. I don't know. It's all marketing at this point. You're not going to see 10.1. Nope. I don't think you'll see 11. It's going to be 10. It's just like, you know, OS 10 on Mac. How long has it been out? Has it been out like 10 years now? Windows 10's been out 10 years. I mean, OS 10's been out 10 years. I think it has. And as we've seen with Windows 10, it started as one product. Windows 10 now is a very different operating system than the original Windows 10. And that's what you're going to see is differences in that. I know Microsoft says Windows 12. That's not what's going to happen. I don't know. Maybe with their new CEO, he's more of an engineering type. Maybe they will do that. Windows Extreme. Now we're talking. Now we can have that. It's the Windows wannabe version. It's the Windows next gen. Now we can come up with some great names. I don't think they're coming off of 10. I think they're sticking with 10. Anything Microsoft actually is really good at marketing. You know, whether they go down the wrong way with their marketing, whether they've got to market something bad, whatever they do the best job at figuring out how to make that sound the best. They got great marketing folks. And they do a very good job of that, because I bought some really bad stuff from Microsoft because they did a great job at marketing it. I was happy to do it. We'll see. We'll see where they go with that and making all of those things happen. The other thing that I ran into today, I've talked already about in this study group. We talked about the crossover cable and how it's not 568A to 568B. We've talked about the layer 3 switch. There's no such thing as a layer 3 switch. Almost said layer 3 router. There's absolutely layer 3 routers, but they're not layer 3 switches. The other one that I just had emails go back and forth today is the Ethernet category cabling standard. That was the other piece. And the cable categories, there's that weird thing for some reason on the internet, I think I know why, where a lot of people believe that category 5 is for 100 megabit and category 5E is for 1 gig networks. And I get why that happened. And if we know the history of it, we do know why that happened. But the reality is a category 5 cable is identical in manufacture to a category 5E cable. It's exactly the same cable. It's not that they were sort of the same. It's literally the same cable. They are made, manufactured exactly the same. The only difference is on the outside sheath. One says category 5 and one says category 5E. Now, how did that happen with that? That's sort of weird that happened. Well, of course, we had this 100 megabit Ethernet network that we were using. We created a category 5 cable that worked for that 100 megabit network, but we realized we need to go faster. So the IEEE said, let's go faster, but we don't want to have to swap out all this cable. We want it to be exactly the same cable, but run gig Ethernet on it. And so we did. We released an Ethernet standard that even to this day says gigabit Ethernet using 1000 base T runs on category 5 cabling. It's part of the Ethernet standard. It's 802.3 standard. It is not, the cables don't have any difference in crosstalk. There's no difference in how they're made. There's no difference in manufacturing. They're literally the same cable. The problem, though, is when we went to gigabit, there's some extra capabilities in gigabit that you don't have in 100 megabit Ethernet. For example, you are able to send traffic on a 1 gig connection in both directions over the same wire. I don't really talk about this much in the exam content because it's not sort of outside the scope of the exam. But that's an extra capability that you don't have on 100 megabit. 100 megabit, there's a transmit wire and a receive wire. On 1 gig, the transmit and receive can occur on the same wire. So that's an interesting feature. Now, because of some of these additional features they added to the standard, they realized, there's some additional tests we should be doing with this wiring to make sure that it will work properly for Ethernet. So let's add some additional tests to the certification process. And these additional tests will make sure, absolutely sure, that the wires that we produce are going to work properly at 1 gig. And so we added those additional tests to the category standard. But of course, because we're adding the tests, we can't call it category 5 anymore, but we'll call it close to category 5. It's category 5E is the test that we're doing. Now, all we did was take the same cable and we just did some more tests to it, and it passed the tests, just like every category 5 cable would pass this test. And we stick category 5E on the side to show people that this particular cable, we've done those additional tests just to make sure it really is compliant to be able to run at gig speeds with those additional tests. But as it turns out, it's exactly the same cable we were using for Category 5. We didn't change anything. And that's why in the standard, you can use either cable because it's identical, the cable. But if you look on the internet, and there might even be more cases on the internet that are wrong than those that are right. But on the internet, you will still find many, many, many references that tell you Category 5 will only operate up to 100 megabits per second. Category 5E is required if you ever want to go to 1 gig. And it is a complete falsehood that has no basis in fact and is contradicted by the 802.3 standard itself. So it's one of those challenges, though, because as you are studying this, you have to answer this question on an exam, and people will say, well, what is CompTIA expecting? Is CompTIA expecting what appears to be the more popular wrong answer, or are they expecting what the right answer is? And I would say they're expecting what the right answer is. Because if you look at Wikipedia, you look at any reliable source on the internet. I just don't mean any third-party website that stuck some stuff up there to update and get a better SEO. I mean, you go to actual definitive sources on the internet, and they all say Cat 5 works great for 1000 base T. And of course, more importantly, for those of you interested, you can download the 802.3 standard for free from the IEEE. They will give it to you. Normally, you have to pay hundreds or thousands of dollars for these standards. That is one of the standards they will give you if you are using this for educational purposes. You have to register on the IEEE website. I think the term to search for is Get IEEE, all one word. And they will give it to you. I have a copy of it. In fact, the PDF has my name on it. They don't like you sharing this. But it has they create a PDF just for you that has my name on it. I wonder if I have it. Can pull it up on the screen so you can see what this is like. It's a fantastic resource. Let me, in my preview, go to my Open Recent, because I was just looking at this as early as today. And I'm going to bring this up. I'm going to try to bring this up on my screen. I was going through some of the things associated with the standards for 10 gig. Here it is. So here's the IEEE 802.3 standard. This is the latest version, which, by the way, is the 2018 version of 802.3. I was looking at Category 5 balanced cable. In fact, what was I looking at here? I was going 1,000. In fact, here is the actual text of what we were just talking about. 1,000 base T requires 4-pair Class D cabling. I'll explain what that is in a moment. With the nominal impedance of 100 ohms, as specified in this ISO IEC standard. The cabling system used to provide the link segment shall consist of Category 5 components. There you go. There it is. It's in the standard, quite literally in black and white. But because this is my version of this standard, it actually says authorized license use limited to James Messer. That's me. Downloaded on September 20th, 2020 at this time. Boy, they really go into details. Restrictions apply. But you can get your own version with your own name on it. It is an extensive document full of plenty of things I don't understand. But I can understand when it says, whoops, wrong button. When I can't understand when it says, this is Cat 5. Okay, well, there's no argument there. We know exactly why that is, what it's there for, and how that works. So that's where I get those things from. And for the exam, Category 5 and Category 5E are perfectly valid and usable cable types to run 1000 base T on. There you go. That's what it's for. Not the crazy third-party websites, or quite honestly, even the Network Plus books get this stuff wrong all the time. We aren't perfect. We're just authors. We're just trying to put this stuff in and do the best we can. And if you do run into a book that gets this wrong, just tell the publisher, hey, you messed up on that one. You may want to go back and have a look at that standard because that's not true. And they'll fix it most of the time. Let's go to the phone calls. The 312 area code. Hi, caller. What's your name? Where are you calling from? Caller. Are you there? Are you muted? You hung up. You had it. You were sick of me. And who can blame you? Let's go to Joe, who was called before, calling from the 202 area code. Hey, Joe.
Hi, how you doing?
Hey, thanks for calling again. What can we do for you?
Yeah, I had well, I know it's a network one, but it's more of a hardware question. But I thought it'd be really important anyway. So there's this feature called HP Fast Boot, and basically it's a feature where your computer skips the BIOS. And one of the problems I've been having is that, well, if the computer skips the BIOS, then I might not be able to actually get in there and do any kind of repair. So one of the problems I was having is if I have a computer that's compromised by a threat actor or something like that, and HP goes into fast boot, and Windows 10 requires passwords to get into fast boot, I'm not really sure how am I supposed to repair that computer without, just wiping out the hard drive. So can you explain, how one might disable fast boot in a situation like that?
I do, and it's not exactly something that is obvious. I'm trying to pull up the details from this. Is actually in my Core 2 course in the troubleshooting section, because as you mentioned, this is a real problem. You imagine having a system that requires you to get in. Maybe you just want to boot from the boot media so you can get to a safe mode. Maybe you want to get to a command prompt on that system so that you can then run some antivirus, anti-malware, and do other things with it. And what if you can't even get there because it won't boot? It won't go through the boot process for you to even be able to do that. It kind of a pain. This is a new feature in Windows. It is fast boot. Let me see if I can pull up my Windows feature breakdown of this. I need to find the configuration file where I have all of these details in it. But there is a way in Windows to get around this problem and to require it to boot during the normal boot process. Now, if you do this, if your system is set up for this fast boot feature, it will simply, when you hit the power button, it simply goes into a hibernate mode. It takes the current file system, the current set of memory, writes it to the drive, and powers off. And then when you want to use it again, you hit the power button. All it does is sort of pull everything back into memory from the drive, and you're back up and running. And that doesn't help you because you wanted to boot from your drive, and now you can't boot it because you don't have access. The system isn't responding to you. You can't do a normal shutdown. It's not working the way you would expect. And even if you try to do a normal shutdown, sometimes it won't. What you do is when it is starting up, you interrupt it. You hold down the power button so that it completely turns off. And you do that 3 times in a row. You just keep doing that. And once you do it the 3rd time, Windows thinks, hey, I think that you want to really restart this thing and have BIOS access and boot from the boot media again. I think that's true. And it finally decides, okay, we're going to restart from the very beginning now, and you'll be able to do that piece. Now, the first time I mentioned this in a study group, people are like, no, you don't just interrupt the boot process 3 times and suddenly, nope, that's exactly the way it works, and it's documented that way on the Microsoft website. That's exactly the way you're supposed to do it. And that's something that is very frustrating in Windows to be able to do that there. It's called fast startup mode, which you can, by the way, disable in the Windows configuration. So if you wanted to not have to go through that process, you can do that piece. But Windows even says you may be in a situation where you can't even install updates because your system isn't restarting. But the folks at Microsoft have documented, here's what you need to do to get around the fast startup process. And by simply interrupting it 3 times, you will be able to do all of those pieces. It's not obvious. They don't give you any instructions on it. It's not something that seems like something you should be doing. In fact, we sort of tell people, wait, don't interrupt the process. You're going to break something. And in fact, that's exactly what you should be doing. Interrupt the process. You're not going to break anything, and it will finally give you access to the BIOS and the startup process normally. Maybe that will help you, Joe.
Yeah, thank you very much.
I think if you're ever in a situation where you have to do this, remember back to that. It will save your life if a system is set up this way, because very often we're sitting down in front of a system that's not ours. We never had a chance to set it up to not use this fast boot process or fast startup. So that can really help you if you need to get in there and get into safe mode, run SFC, get to the command prompt. It's a lifesaver.
Okay, yeah. Thank you very much. Thank you.
Absolutely. Appreciate the call, Joe. Best of luck.
You too.
This is one where it's just not obvious. Folks in the chat room saying, oh, yeah, I just had to figure this out this morning. It's really annoying if you're in a situation where you have to do this and it's not working for some reason. And it's not obvious. I think they should almost put something on the screen that says, restoring from fast startup, hold down power key 3 times to interrupt or something. Maybe they'll do that in Windows 11. That's what they'll do that we're not going to have. We won't be able to work until we do those pieces. The fast startup process, I think I've got one on here where I can show in my videos. Fast startup is the Microsoft term for this. And of course, my searches aren't doing very good with the fast startup. I think I have it in a different category to be able to make that happen. Let's see, there it is. It's under my troubleshooting solutions video, section 3.1 of the breakdown. And I will bring it up so that I have too many slides in this one to be able to have this here. If I would search for startup, it might be a little faster. Fast startup, safe mode in Windows 10. This was a new feature that started in Windows 8, 8.1. I guess 8 and 8.1 in Windows 10. Fast startup. You can hold down the shift when clicking restart. That's one way to get there. All right, that helps. You could click settings, update and security recovery, advanced startup, restart now. That's so easy to remember. Why aren't we doing that? And then the last is change it in the system configuration. Or the way I do it, which is never remember to do this beforehand, and finally just interrupt the normal boot process 3 times. I know you can't see that very well because it's hidden by the phone number. Here, we'll get it to go right there. Great. Now you really can't see it. Glad I was able to provide that to you. So that's what you do. You interrupt the normal boot process 3 times. And that gets you to where you need to go. That will get you around that problem. As annoying as that one is, that might help you when you're getting through this. Let's talk about how long it takes to study for Network Plus. Question in the chat room from Monica asks, is a month enough time to study and test for Network Plus? It could be if you are familiar with the technologies associated with Network Plus. But I'm going to bring up some information on my screen, and we're going to step through this real quick. So let me bring up the Network Plus pieces I have, and I'll tell you what other people are doing with Network Plus. These are the Network Plus exam objectives. Let me have these on the screen. There we go. Network Plus exam objectives, they are extensive. Now, mine are colored because I use these exam objectives to build out the videos. Everything that's green are pieces that were already covered in previous versions. The yellow were not, so I had to update these. But look at the details. Here's just section 1.3 of Network Plus. There it is on the screen. There's a lot of detail in this exam objectives. Properties of network traffic. You have to explain the concepts and characteristics of routing and switching. You have to know the properties of network traffic, which include broadcast domains, CSMA-CD, CSMA-CA, collision domains, protocol data units, MTU, broadcast, multicast, and unicast. You also have to know segmentation and interface properties, which include VLANs, trunking, which is 802.1q, tagging and untagging ports, port mirroring, switching loops, spanning tree, PoE and PoE+, which are 802.3AF and 802.3AT. I never remember. DMZ, MAC address table, ARP table, routing protocols, blah, 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 IPv6, addressing, tunneling, dual stack, router advertisement, traffic shaping, QoS, diffserv, NAT, PAD, port forwarding, access control, distributed switching, software-defined networking, and more. And that's just one part of a section. That's section 1.3 of a very large domain that has 8 sections in it. Okay, So already, from my perspective, there's a lot to know just in section 1.3. Now, if you're someone who's already been working with these technologies before, that may not be a big deal. You may be able to get through that section in an hour and you're done. Like, yep, I know that one. I know that. I know that. CSMA-CA. Let me go remember what that's about. Okay, got it. Let's go to the next. And you can go through this list and check these off. But if you've never touched a network before, this might take you some time. Some people are able to go through this entire list, make sure they really know everything that's here, and they take the test in a week. And this is people that have been to my site that tell me this. I would say the vast majority of folks, the average, I won't say vast majority, but the average of people that are taking this exam usually take 2 to 3 months before they are taking the exam. So that's a little bit more than the 1 month you had mentioned, Monica. 3 months is kind of an average one. 3 months is a good number. And all you have to do is go through this list. Go through each one of these things. It's your checklist. Check off, do you know all of these ports? Do you know what all these protocols do? Do you know the OSI model? Do you know section 1.3? And you just keep going through this list and checking off each one of these things as you go through it. That's the real key, I think, for anybody taking this exam, is just knowing this. And most of these are acronyms. This is probably the most acronym-y exam between the A+ Network Plus and Security Plus. Is that a word, acronym-y? I think it is. It absolutely is. And that's what I'm going with. This is an exam with a lot of abbreviations. So you should become familiar with those. In the back of these study guides and back of this exam objectives, by the way, are the acronyms. So if you want to get acronym-y, this is where you would go. We're going to make this a thing now. These are all the acronyms that you need. Now, as I mentioned, knowing the acronyms isn't going to help you. Knowing that DLC means data link control does not help you at all. Don't waste your time trying to memorize that. You should instead start memorizing, what is data link control? What is that even referring to? Oh, it's a way to refer to the layer 2 address, which we commonly call MAC addresses on Ethernet, or media access control, and they have this format. And that's what we use to be able to make routing or forwarding decisions and switching. And it's on wide area networks. It may be referred to as a DTE and a DCE. That is the level of information that's useful to know about data link control. Now, that has nothing to do with knowing that DLC stands for data link control. I guess ultimately it's important you know that, but that's only the top level of what you need to know with that. You now need to know everything about what that means. There's others in here you're not even going to use. DLR means device level ring. That's not even a thing. I think they put fake stuff in here sometime. That's not a thing. Device level ring. What? That's not a thing. Is that a real thing? I don't think it's a real thing. Never heard it. Maybe it is a real thing. I've just never heard it. Maybe I'm just not good at this. I've only been in the industry for my career, working with the highest level of technologies. And occasionally I'll go through this list and find things that make no sense whatsoever. Fortunately, the vast majority of this list, as I'm looking through it, recovery point objective, Revist, Shamir, Edelman, remote shell, rapid spanning tree protocol, recovery time objective, real-time protocol, real-time streaming protocol, round-trip time, real-time time, security association, software. These are all real things. The vast majority of this is real. But occasionally you will find things that just don't quite fit or have any context into what you need to know. So don't deal or worry so much about the list of acronyms. You will learn the acronym and what it is as you go through the actual exam objectives, which are the first set of pages, those 5 domains. So as you're working through the domains, you will run into switching, which forwards information based on the DLC address or MAC address. All right, well, there's 2 acronyms you just ran into. And by learning the objectives, you are effectively learning the acronyms. That's what that's about. Do my course notes follow the videos in order or the objectives in order? Well, as the case may be, I don't know if you're aware of this, my videos are exactly in the same order as the exam objectives. So if you go to video, go to section 1 of my videos, it is on protocols and ports because section 1.1 is protocols and ports. My video 1.1 is protocols and ports. My video 1.2 is about the OSI model. So the challenge I have, and the challenge that many of you have found, is that your books do not follow this format. They don't go in this order. And there's a good reason for that, which is the order listed in the CompTIA exam objectives, probably not the best way to learn this content. So why are my videos in this format? Because quite honestly, many people watching my videos are not following them in this format. They're reading it in the book. They're going through the OSI chapter in their book, and they're thinking, oh, I need to learn more about the OSI model. Does Professor Messer have a video on OSI model? Oh, yeah, he does. And I'm got my exam objectives. I know OSI's section 1.2. Hey, look, video 1.2, OSI model. That was easy to find. Let me watch that video. Now, I realize there's other ways to search for things on the internet, as it turns out, but many people do use the objective numbers to do that. Some people do go through these videos in this order, and it's not awful to do it that way. It's probably just not the most conducive to learning this at a fundamental level. But at the very beginning, when I started creating videos, I started with an A+ series. And I looked at the A+ exam objectives and I said, these objectives are not in an order that would be the most optimal for learning these technologies. I'm going to reorder everything as if it was a book, like the books you would buy off the shelf. And I'm going to put it in an order that makes sense for how I would like to teach it. And I did that. And then people said, I can't find anything. My book has it in one place. Your video has it in a completely different place. I can't find anything. And I realized early on, there's no good way to do this. There's no perfect way to number and put these videos in a particular order. So I decided the exam objectives will be the order I do my videos in. Doesn't mean you have to watch them in that order because they are very modular videos. You can pull a single video out, watch that video in a world unto itself for the most part, and it covers topics that are self-contained. They don't require you have watched anything before. They don't require you watch anything after. They're really just focusing on one particular thing. So they have a very specific niche. They are not designed to handhold the beginner through the very early details of networking, but you can get there if you watch the video series. There are video series out there that are designed to take you, explain it like I'm 5 and take you up to where you need to go. And those might be a better video series for you. But some people already have kind of a basic foundation, and what they need is just more context. That's how I built these videos. So that's where, whenever I start getting into this, that's where I focus on that, and having those show up. And that's why when you start seeing my videos and you're wondering, why are they in this order? And why is he kind of jumping into the middle of this without any type of hand-holding? That's why. So kind of a different idea to have that there. Let's go back to phone calls. We go back to 786. Hi, caller. What's your name? Where are you calling from?
Hi there. My name is Joshua, and I'm calling from Miami, Florida.
Hey, Joshua. Thanks for calling. What can we do for you?
So recently, I'd say about a month ago, I had a cloud support interview, but I didn't get the offer. And one of the questions they gave me was, it was 2 interviews, a technical and behavioral.
Wow.
And one of the questions was, they were having issues connecting to the internet, and they told me what I should do to troubleshoot it. And I was wondering how I should approach that problem.
So they're just sort of generically telling you, I can't connect the internet. What do you do next? Kind of thing. Is that sort of the broad question they were asking? That's a pretty good question for an interview. Take you through, because it kind of expects that you've kind of been there before. It's kind of hoping that you were you've been in a place where you can start asking questions about this, I think it's a pretty good interview question. So let's break it out ourselves. So all we know is as the users will tell us, the internet's down. So there's no more internet. Apparently it's out around the world because I can't get to Google. So now what do you do? And it's kind of a combination of things. And it may be, and if I was in this interview, let's answer it like I would answer it, whether this is good or bad. I tend to go through the process of asking a lot of questions first and sort of doing a lot of Q&A to kind of build a knowledge base of what I know. And since we're sort of in this interview process, they probably would like to play along with this to go, okay, do you happen to have the error message on your screen of what it's saying? And they might or they might not. They might say, yeah, network cannot be found, or IP address unknown. And they might just say, no, I don't have that error message. I just can't get to Google. It says nothing's happening. It just sits here. That's kind of the normal thing for any user. Do you have then we can even play around with it and say, do you have a screenshot you can send me? How you do that? I don't know how you do a script. Okay. So let's now start at the bare basics of minimum where we just don't know. What do we do next? Well, we can start with confirming that this device is even on the network. Can this device talk to anything? Can it talk to itself even? Would be a good thing to know. So if you were to sit down in front of this workstation, because we're assuming that perhaps we can't remote desktop into it because it doesn't have a network connection. You're sitting down. First thing you'd like to know is what is the IP address of this device? Can we even see, does it have an IP address assigned to it? And what is that IP address? Is that IP address one we would expect? Is it an IP address that is an API-PA address, which is an automatically assigned IP address? Because that might tell us that perhaps DHCP is down. If it's a 172.16 through 20, one of the, no, it's 172.16, that's legitimate. You're actually on the network at that point. But if you have anything in the API address range, that is one that's going to be a big problem for you, the 161 range. So if you get that, now you can at least tell them, well, there's clearly a problem with the DHCP. Let me get the DHCP people involved. But let's say they have a 10 dot address. Let's say they have a 192.160 address. Let's say they have a 172.16 address, and they're on the network. And it's not one of the 169.254 API-PA addresses. So if we're now at that point, let's see if we can ping ourselves. Can we ping a loopback address? Can we ping our local IP address? Can we ping our default gateway? If we can ping up to our default gateway, we at least know we're on the local network. At that point, it would be useful to know the internal infrastructure, know what is the next router after that, what's the next router after that. Maybe we would run a trace route to 8.8.8.8. That would at least tell us to go to that route, what the different routes would be. And we can kind of see our internal routers. We can see our router to the internet. We could at least get an idea. Can we ping all of those, assuming they're pingable? Can we get to that point? So we can start building out how far am I able to communicate to be able to do that. That gets us to a certain level of understanding why we can't get to the internet. And if we've already run a trace route to 8.8.8.8, we can kind of see how far we can get, and we can see what router is available and not available. And at that point, we may even want to pull in our networking team because we've already confirmed it's not the workstation. It's not the local router on this person's subnet. The DHCP server is working properly. Our cabling is set up the way we would expect. We've got no problems with those. Now we need some help from the networking team to understand, hey, I can ping all the way up to this router, and then this user can't ping anywhere past that. What do you think that problem might be? And you bring in more people to be able to answer that. When you get into those situations, I don't think the person asking the question wants a definitive answer. What they would like to know is, what is the process you would go through? What would you check first? What would you check second? What would you check third? And sometimes they want you to start at the OSI layer at the bottom. Did you even check the cable? Was it even plugged in? Because that's sometimes the best place to start. I didn't even start there with my troubleshooting. I just assumed it was plugged in. I failed. I didn't get the job either. Joshua. So, but at least you gave them an idea. Here's the things I would check. Here's the problems I would run into. Here's the scope of my abilities. And then here's where I would pull in somebody else to help me out with this, and ping them and send them a text message or whatever it would be. And that would at least get them understanding, yes, you understand the technology. You know how the network operates. You know where the big stumbling blocks are. And then here's where you could start adding on to that list and gaining more information about the network infrastructure. I think that would be a pretty good answer, Joshua. That would at least get a more conversation going, and at least have the people on the other side of the table know that you're thinking about the process and what you would go through. And do this at home. Try disconnecting your connection where your internet is. See how far you're able to ping in your home office, in your home lab, to try to get out to the internet. Where does it stop? If you unplug the cable from the cable modem, how far can you ping? If you power down the cable modem, how far can you ping and why? Those would be interesting things to see. And then you can use that knowledge and apply it into one of these situations with an employer or prospective employer, where you could say, well, here's what I do on mine when this happens and why I do it this way. This would probably work in your environment as well. Does that make sense?
Yeah, I feel as if I should have asked more questions.
One of the things I think we're so worried about as technicians is looking like an idiot. I feel like the parts in my career where I've learned the most is when I've been the idiot, is when I don't know what's going on, or I've had to fix something that's broken, are the times when I've really learned the most. And the thing that really changed in my career is when I started sitting in the front of the room, and when people giving me the training would ask the question, because I'd usually work for manufacturers. We would go to training. It would be a week out of town. We'd go to these breakout sessions. We'd spend an hour in a room talking about a product, and they would go through these scenarios. And when you're in these meetings, they would always ask, anybody have questions on that? And this is usually what you hear. Nothing. Nobody ever asks a question. I would be the one that would say, yeah, I have no idea what you're talking about. You went here and then you did that. How'd you get from point B to point C? I'm not following that. I missed that completely. Probably because I've never done that before. I don't come from that background. I come from this background. So I'm missing a gap there somewhere. And they go, oh, well, that's because of this. And then they go back and explain that piece. Okay, now I understand that. Please continue. Let's keep going. And almost always in those situations, one of my associates who works in the same job that I work in a different part of the country, doing the same thing I do, would come up to me afterwards and say, I'm really glad you asked that question because I had no idea what he was talking about. I'm like, well, why didn't you say so? Because I didn't want to look stupid. Like, well, I have no problem looking stupid. I'm fine with looking stupid. I don't want to be stupid when I leave. I'm fine being stupid in the room. I just want to be sure I understand it before we get out of there. And I know that in those situations, you can't learn everything all at once. But if you really aren't understanding something, that's the time to ask the question. I used to sit in front of customers all the time representing different technologies. And if I'm sitting in front of them talking about next generation firewalls, you don't just walk in the room and say, all right, I've got the firewall for you. Where should we plug it in? You would never do that. You'd actually say, yeah, I know you guys have an old firewall here. What are some of the challenges you're having with your existing firewall? Well, it doesn't have good reporting, or we can't block malware, or it's allowing through these VPNs that people can get, and we don't want our students to use a VPN. They're circumventing our existing security controls. Great. Those three things I can fix for you. But if I had never asked the question, I would be going off on a tangent, showing them capabilities on auto configuration, and here's how you set up the IPS. Well, they didn't need IPS. They didn't want any auto config. They just wanted these three things. So asking questions is a key part of what we should be doing in our industry. We don't do it enough. We're so worried about looking stupid. As soon as you start not worrying so much about looking stupid and instead wanting to have a conversation with somebody about things you know or things you don't know, it changes the room. People in the room who were trying to figure out what you know now have a pretty good idea about what you know and what you don't know. But more importantly, and I think we kind of missed this point in technology as well, we're having a conversation between humans, which we don't sometimes realize is the most important part of IT. We're so focused on operating systems and bandwidths and interfaces and security policies that we forget the most important thing is the ability to have a conversation with someone, which, by the way, gets you past a lot of problems. I plugged in a lot of firewalls and configured a lot of systems in my time. And the time where we've had the most amount of good conversation and the most amount of fun is when we can just talk about these things and I can ask questions about what someone's doing. I used to walk into different environments all the time. I'd have a meeting in the morning at a college. I'd have a meeting in the afternoon at a manufacturing facility and another meeting after that at a company that does transportation. Maybe they're an airline. I have an interest in all of these. Oh, you have a lot of students here. They must kill your wireless network. What's that about? Are they really just really using the wireless network, or is this, how do you manage that? They go, oh, well, here's how we do that. Because I wanted to know. Then we go to the manufacturing company and I say, well, this is like a 24/7. How do you handle this at night? How do you handle monitoring the network and keeping things up and running? If the manufacturing line goes down, you're losing money, aren't you? And they're like, yeah, and here's how we do that. And then we go to the transportation company and you're dealing with time zones and equipment that's very high scale. It has to handle huge amounts of different traffic flows. Holidays, suddenly there's huge traffic flows. Nighttime, it gets quiet. How do you handle that? And we got to have a conversation about it. Those are probably conversations had nothing to do with the firewall that I was plugging in, but I got a better understanding of the things they had to deal with on a day-to-day basis. And there might have been some features in the firewall that can kind of help them with some of the things they were having to deal with. But the important thing was that I didn't come in knowing their business. Let me tell you how you really should be doing things with your firewall. I don't know. You know best. It's your network. Let me show you a few things, and you can tell me if I'm heading down the right direction. I think that's some of the best ways you can handle those situations. It helps you in a situation with interviews. It helps you day to day. It helps you in working with third parties. And it's a good skill to have. It's a skill you have to learn, a skill you have to really keep working on. But there's always a question to ask and always something you should be interested in. And if you can kind of get that interest across to someone else, you can have some pretty good conversations and maybe get a job out of the deal, Joshua.
All right. And I had a follow-up question.
Sure.
So when we were doing the troubleshooting question, they gave me another question was, they said, what if the network, the user's network was working fine, but it was our server having issues? How would you troubleshoot that?
Well, hopefully you told them that you would lie to the users and tell them that everything was fine and it was something that was in their minds. And then you would go from there. Well, I guess it would sort of depend. Now you start asking more questions about what is the application that they're using? What is it that they're connecting to? Is it a web browser? Is there a separate application on the back end? Is there a database associated with that? Is there an applications team that handles that piece? Is there a web server team you can deal with? And then you can start, do I have access to the user's machine? Can we see what they're seeing? Are there screenshots associated with that? What's the error that they're running into? And then you could start parsing out from there where the problems might be. Are they getting an error that's a networking type of error? Are they getting a browser that's showing a reset message? Are they getting one of those weird Chrome messages? Or is it a problem with a certificate? Those are easy things to fix, and they're very obvious messages. Or is it something with the application? Are they able to log in properly? Is it just slow for them? Are they getting a message in the application? Depending on what the message is, I'm going to call different people. If it's a problem with the certificate, I need to call the web server people. If it's a problem with an error message when they're trying to perform a function once they've logged into the application, I need to get the application people on the phone or forward the ticket over to them. There's different people in different contexts depending on the error that they're seeing. it's another one of those situations though where they want to see how you would troubleshoot it. They're probably not looking for you to fix the problem. There probably isn't a fix with that sort of a broad problem like that they're giving, but they want to know, how do you get from point A to point B to point C to point D? And then ultimately, where do you go from there? Because you're probably not going to be the one to fix it, but you need to know how to properly redirect this problem to the right group. And the right group would appreciate it if you did that too. So this is one where understanding the basic functionality of setting up an SSL connection through a browser, understanding an authentication problem, understanding an application issue, and knowing what those errors might be can help you better categorize where the problems may be occurring. And then you can kind of take your best guess based on what we've just talked about. My best guess is that the problem is associated with the database, and let's get the application people involved and see if they can replicate that in their lab. Yeah, I think that's a pretty good answer. Whether that's probably the concept they wanted. And since there isn't, the problem isn't actually happening, that's just as good an answer, I think, of it as anything else. We've now taken this issue and gone down the road, and they might redirect you as you go. Like, oh no, the problem is not with the certificate, it's after they log in. Okay, well now we know it's really something focused on the application. Let's drill down on that. Now that I think is a more common way to go through these problems in an interview process than anything else. And it's kind of reminds me of the first question they asked, where it's a broader question, but it's up to you to know where you go first to troubleshoot this. And on both of these questions, by the way, and almost always, we're starting at the user's workstation, and we're expanding the circle out farther from there. If the server was down completely, you'd be getting 100 calls coming in. The server is down. So that's probably not our issue. And maybe you can even start by saying, if it was the server not working, everybody would be getting a phone call and there'd be 100 people in the queue. But let's assume that's not the situation. Let's start at the user's workstation and ask questions about what they're seeing. And then go a little farther out. Are they connecting to the web server? Yes or no. Are they getting an error message? Yes or no. Is it a certificate problem? Yes or no. Okay, they're not. Let's go a little further. Are they able to log in? Okay, they got that far. Are they getting any messages when they log in? No. Are they getting into the first screen? Yes. Now what happened? So we're able to keep expanding the circle until we get to the point where the problem's happening. If you can keep doing that and keep expanding it out, and ask the user what they're planning to do this weekend, and keep the user happy on the phone, then you've probably got a good chance at answering the question in a way that makes the prospective employer happy with you as well.
All right. And is this being recorded so I can watch it again?
Yes. As with all my study groups, the recording is available to watch immediately afterwards when we're done. It takes a minute or two for YouTube to process the video, and then it's available immediately afterwards. And I post the podcast version of it usually in the afternoon after we're done. So a number of hours after we're finished, but absolutely you can always go back and go through it.
All right. Thanks.
Thanks. Appreciate the call, Joshua. Best of luck. It's kind of a challenge if you've never been in one of those help desk roles. Getting a job in IT with no experience is a challenge. I guess this is a good point for me to kind of talk about the video I created, which was how to get a job in IT with no experience. Because I think there's 4 good categories, 4 elements, I call it in the video. It's a 30-minute video, so more time than we have here to go through the details of it. And it's a video I made that's just full of content. The first thing is have a formal education. A lot of employers want that. And I realize we can have a fist fight about that one, whether that's valuable or not. But employers are still asking for it. So that's a good reason as any to have a formal education. The second one is to have some type of certification in the industry. And you're doing that now. You're getting an A+, a Network+, a Security+. Having that certification adds additional context, additional info as to what you learn from your formal education. Because quite honestly, many of the formal educations don't go into details like A+, Network+, and Security+ does. Third on the list is to have some practical experience. Well, if you haven't had a job yet, that becomes a challenge. And I think these questions kind of speak to that. Where do you get the practical experience? And I think one of the things you can do is to build your own lab. And in the video, I think I have 2 or 3 different scenarios I give on great labs to build. Build a Microsoft Active Directory lab. Build a pfSense firewall lab. These are great ones to do because now you have some practical experience working on an actual firewall. Practical experience working on actual Active Directory. Setting up your own users. Changing their passwords. Deleting their accounts. Suspending their accounts. Connecting their machines to the network. That's good stuff. You walk into a help desk role and go, oh yeah, I've got my own Active Directory at home. They're like, you do? Nobody has their own Active Directory at home. Yes, you do. And here's what I've done with it. Here's what I've set up on my Active Directory at home. That's a pretty good thing to bring into a scenario, especially if you can talk about the challenges you had setting it up. And if you talk about how it was so hard to get DNS running. I don't think I mentioned that in the video. Active Directory, people in the chat room, Active Directory is simple. Active Directory is not simple. It is a bear. It looks like it should be simple, but it is not. And if you talk at the very beginning, yes, let me explain to you how important DNS was to Active Directory. If you even know that, if you even understand the relationship between DNS and Active Directory, and you can explain that to someone else, you're well on your way. The 4th element that is so important in getting a job in IT with no experience, knowing someone who works there. I don't mean knowing somebody like you grew up with them, you were best buddies. I mean, it's a neighbor from down the street. It's somebody from church. It's a friend of a friend. Maybe you met them at a meeting. Maybe you met them at a Cisco study group meeting, or you met them online in a Discord. And they told you about this job, and you can reference them in the interview. Oh, yes, I know Bill in IT. He lives down the street from me. Oh, okay. Knowing just that connection is important. Oh, okay. Well, we know where you live. We know, people who work here have interacted with you. They would not have recommended you for the job if they thought you were inappropriate for it, ostensibly. So that gives you some points. Additional points are important. In fact, knowing someone is a lot of points. They don't tell you that. Well, they sort of tell you that. You always hear the thing. It's not what you know, it's who you know. There's some reality to that. It actually is both. It actually is both what you know and who you know. But the who you know counts for a lot. Don't discount that. And if you don't know someone who works there, you haven't been working hard enough, you even might know somebody who works there and not know it. Go to their LinkedIn. Who's part of this company? Is it anybody I know? Do they know somebody I know in their LinkedIn? Is there a connection to any of these people? Maybe someone you know knows somebody who works there. Hey, can you introduce me to this person here? I have an interview there next week. I would love to ask them a few questions about things I should maybe know about. That's what doesn't hurt sending an email. Doesn't hurt reaching out over LinkedIn. All they could do is not respond to you. Okay, you're exactly where you was. You started. That's fantastic. Nothing was harmed. There was no problem in doing that. They just didn't want to talk to you over LinkedIn, I guess. I do get that from time to time. But I use LinkedIn all the time to reach out to people I used to work with, to keep track of what people are doing. It's a great professional way to connect with people who might be at another company. And I've known people that said they're going into a company for an interview. They go to LinkedIn without knowing anyone there, find somebody who works in IT, maybe at a management level, and just sends them a message. Hey, I'm coming in for an interview next week. And I know you may not be part of that, but I'm really interested in working for your company. And is there anything you would recommend I should study up on before I go into my interview? And maybe you start to have a conversation. And then in the interview, you now get to say, oh, I had a conversation on LinkedIn with Bob in accounting, whoever it happened to be, Fred in IT. And we talked about the challenges you have with setting up this infrastructure, the big project you have going on, the need for having good people in the help desk that know about Active Directory. Here's some things I've done along those lines. Doesn't hurt. So those are things you can absolutely do to maybe get your your interview a little further along than it was before. And just don't be afraid to say, I don't know, but I do know how to find out. Because you're not going to know everything. In my last job as a systems engineer for a next generation firewall company, there's no possible way you would know everything about everything. I would spend all day, every day, learning everything I knew about this product and still did not know everything about this product. And I worked there 7 years. So that's one where you have to know where your resources are. You have to know where your limitations are. And then at that point, well, I don't know this. Who can I talk to? You know, one of the things I didn't have a lot of experience on at that time was BGP. And I could set up BGP at a basic level, but enterprise complex BGP configurations wasn't my bailiwick. But I had a person I could call who had done that, and they just knew it cold. So if I ever walked into a customer and they said, we have all these questions about this multi-area BGP that we've got set up, and here we're going to set it up this way, and here's the configuration, and we're doing this. I said, well, now you've hit my limit on what I know with BGP, but I have the BGP expert we need to talk to who knows all this stuff. Let me get that person involved with this. We do that all the time. My expertise was on the API side. So if anybody needed some type of context on how can we make the API do this? How should we program to be able to make the automation work and the orchestration for the firewall work? Got it, because that's where I had focused my efforts. And then I could call the BGP guy to answer BGP questions. It was perfect setup. Focusing on a niche, you will find in your career becomes very valuable. And it doesn't have to be a very detailed niche. It doesn't have to be one where you are completely knowledgeable in everything there is to know about that niche. But the fact that you would know more in that niche than most people makes you more valuable. For me, it was the API side and some other aspects of network management and protocol analysis because that was my background. But there was always someone I could go to for those other pieces because they all came from somewhere else too. I think we were really hired that way. When I started with this company, I think I was the 95th employee, and there were, 4 systems engineers, 5 systems engineers in the whole company. Now there are thousands of people that work there. So it's grown quite a bit. But at the time, we had to pick and choose kind of a good overview. Everybody had their own strengths, and then we could get those people together and call on the ones who had the best knowledge for that particular thing. Especially when something like next generation firewalls, when at the time, that was a brand new technology. Nobody had even seen it. Nobody believed it actually worked. Honestly, I would go into a meeting, I would demonstrate this, I would show its capabilities, and we'd come out of the meeting and they'd say, that's just nonsense. What you showed us in there does not exist. Does not. And that's sort of the fun of technology, isn't it? Because you're always surprised. There's always something new. There's always something pushing the edge of what happens. Now, of course, next generation firewalls are normal. Everybody's got one. Of course they work. They do exactly what they say they're going to do. But at the time, nobody had ever seen anything like that. Well, then how do you talk to somebody and get across a concept that seems impossible? That's just one of those skills you have to work on in IT and connect at people sort of at a personal level. And I've walked out a lot of meetings where they said, that Messer guy's just an idiot. He doesn't know. What? He was telling us stuff that can't possibly exist. It was hard to get some callbacks on those things. But finally, the industry changed. It took about a year of what I called education in the field, of kind of showing people, you don't believe me? I bet you aren't going to plug it in and watch it happen, because I got a box right here, and we plug it in. It actually would do it. Those are the times when you're like, that was fun. Let's do another one of those. That's kind of where you should be focusing on in your industry too, and whatever you're planning to do. Find the thing that's exciting to you. Find the thing that makes you happy. Find the thing that is interesting to you every day. And if it's not, find that next thing. I worked a lot of jobs where it was not the thing I should be doing. I picked a bad job to be in. It wasn't interesting. I thought it was going to be one thing. I was wrong. Let's go to the next thing. IT allows you to do that. probably more than any other industry in the world, IT gives you flexibility. It gives you the ability to go anywhere you want to go and do anything you want to do with technology. I traveled the world. I had a job where I was international. I had other jobs where I was very local. I got to decide what I wanted to do. So you decide that too. All you got to do is just put in a little effort, learn about these technologies, drill down on the niche you're interested in, hone the skills that are going to get you there, and the job's just waiting for you. The job openings are there right now. All you have to do is decide that's what you want to do with it. Well, that brings us to the end of, well, we're over our time for the after show. So brings us to the end, whatever that happens to be. But it's not the end. It's so long for now. But what's interesting about today's study group is I literally have another study group tomorrow at the same time. Tomorrow, we're going to do Security Plus. The SY0601 study group is tomorrow at 12 noon Eastern Time. I reset this whole thing. We got a whole new set of questions, a whole new set of ideas and thoughts, and of course, a completely new after show because you get to ask me the questions. So we'll do more of those afterwards as well. Thank you for being here. Thanks for your first hour and sticking in there and giving me the answers. And thank you for your questions in the after show as well. We always have a good time with those conversations. Don't forget about the study groups for tomorrow and the calendar where all of those are. You'll find those at professormesser.com/calendar. Thanks for being here. We will see you next time on the Network Plus Study Group.